Alrighty, a very good morning, all of you, and good morning to Mr. Ang Wee Singh, Executive Director of SSIA, distinguished speakers, partners, and friends. A warm welcome to the second edition of Semiconductor Business Connect 2022. My name is Fiona Lowe, and it's my pleasure to be your MC today. Now, this year's event is themed Strengthening and Growing the Local Ecosystem. And this platform aims to do so by facilitating innovation through business collaborations. Now, SSIA would also like to take this opportunity to thank our sponsors and partners for making today's event possible. So can I direct your attention over to the screen to see? Here are our platinum sponsors. Our standard sponsors, supporting corporate partners, and supporting partners. So ladies and gentlemen, now without further ado, I would like to invite Executive Director of SSIA, Mr. Ang Wee Singh, up on stage for the opening address. Mr. Ang, please.
So good morning, everybody. Now, firstly, I would like to give special thanks to the Minister of State for the Ministry of Trade of the Industry and the Ministry for Culture, Community and Youth, Mr. Alvin Tan, as our guest of honor for today's event. Unfortunately, MOS Alvin will not be able to join us physically today because he's traveling to Mexico. That said, he will have a video to address us right after my speech. And to all the industry leaders, partners, friends, and the hundreds more that have joining us virtually, thank you for your support and your presence here today at Semiconductor Business Connect. This is SSIA's very first major physical event since the recent relaxation of Safe Management Measures, or SMM. We are finally moving back to some form of normalcy and starting to live with COVID as an endemic. This is indeed a great milestone for all of us. And we will start to see countries around the world gradually opening up their economies and borders too. We are starting to see businesses gaining momentum and are on their way back to the pre-pandemic days. We'll see more business travelers, which kind of explain why some of our friends are not here today. And we'll see more physical meetings and more business networking happening too. So this SFM relaxation couldn't have come at a better time. It gave us the opportunity to organize this year's Business Connect at a larger scale and with more opportunities to network and catch up with friends. We hope this will start to bring back the industry vibrancy and to help business thrive. This will also be in line with our mission and vision to make Singapore a successful and a competitive global semiconductor hub. With the news on global chip shortages, we know our industry is in the limelight these days. Despite the many uncertainties we are seeing around the world, our industry continues to grow. The surge in demand for chips is further fueled by the digitalization trend and adoption of new technologies such as 5G. We expect this to continue beyond the next 2 years. Semiconductor companies around the world are expanding their capacity now to address these shortages, both short-term and also long-term. We are seeing some of these companies expanding their facilities here in Singapore too. Companies like GlobalFoundries, UMC, and Siltronics are investing to build new facilities here. While this is great news for Singapore, we need to ensure that our talent pool and also the local ecosystem capability expands in tandem with the industry growth. This is why SSIA is focused on 3 major work streams to help support and grow our industry. Firstly, is to develop and grow our workforce. Our talent pool is our greatest asset. Secondly, is to help strengthen and grow our local ecosystem because we believe a strong ecosystem will support the industry better. And finally, to support businesses in their sustainability journey. Semiconductor Business Connect is one of our platforms in line with the objective of these work streams. This event promotes the initiative to strengthen and grow our industry's ecosystem by supporting innovation through business collaboration. Semiconductor Business Connect aims to connect the semiconductor network of companies to innovate solutions and, most importantly, to collaborate for success. Last year, we had close to 40 companies participating to collaborate for success, both multinational company and SME, despite organizing it at a much smaller scale. This year, I'm happy to see an even stronger support from companies. Many of the exhibitors outside are local companies with great solutions for our industry. They will present solutions in the space of automation, artificial intelligence, sustainability, and many more. So find time to visit their booth and to engage them. Some of these companies are new to our industry despite having extensive experience from the other sectors. So do approach them with a partnership view. They have wonderful solutions, but they will need our guidance and most importantly, your support to meet our industry needs. So please have a fruitful networking session later on. You can use the one good card that's to start your journey into the digital name card. And you can find it right in front of you. I'm sure many of you have started to register your profile. Now, this morning, we also listened to some of our industry leaders speak about topics related to our industry trends. In the afternoon, we have the opportunity to listen to some of our local companies speak about their technology and innovation to support our industry needs. I would like to take this opportunity to thank all our speakers for their sharing. Now, Semiconductor Business Connect is not the only event to encourage business engagement in our industry. I would like to take this opportunity to remind everyone of the upcoming Semicon Southeast Asia in Penang from 21st to 23rd of June. We have our friends from Semi today, both Linda and Travis are here. You can find more information about the event then. Now, I hope to see more business matching engagement happening at Semicon too. I will also be there to support the event. It is important more than ever today that we work together as trade associations to support our industry's growth, not just in Singapore, but the region. I hope our companies can engage the various platforms that we have established to their business advantage too. Now, I would like to take this opportunity to touch on the topic of sustainability. As I mentioned earlier, the semicon industry is expanding due to the surge in chip demand and is expected to grow further in the coming years. However, chip manufacturing creates a huge carbon footprint and will significantly impact the environment too. There is a huge opportunity for our companies to do better in the space of energy and water savings. I would like to congratulate ST Microelectronics for their announcement of Ang Mo Kio's Industrial Park district cooling system with SP yesterday. Their solution is expected to cut up to 120,000 tons of carbon emission annually, or equivalent to taking 110,000 cars off the road, and I quote, not including the electric vehicles. So this is just an example of opportunities for our companies to do better in the space of energy and water savings. With this in mind, SSIA will organize this year's summit with a team to discuss critical topics on advancing technology in a responsible and sustainable way. And as usual, the summit will be followed by the semiconductor dinner. So this year's summit and dinner will be held on 29th of September. So do mark your calendar. It will also coincide with the starting week of Singapore Formula One Grand Prix. I will be sending out more details with regards to this conference and dinner soon. We will have a wonderful celebration at the end of this year. Now, as our industry grows, SSIA too will continue to transform to better support the growth. I'm happy to announce that SSIA Secretariat will also be expanding in tandem with the industry growth. I would like to take this opportunity to thank EDB and the SSIA board for their strong support in this matter. You will see us organizing larger scale events and more initiatives relevant to our industry needs, and hopefully with greater impact to our industry here in the region too. I also hope you will invite your business partners and suppliers to join the SSIA network of companies. This will further help our goal to create a more vibrant business environment for our industry to thrive. Finally, I'd like to take this opportunity to thank all the sponsors and supporting partners for this event. Your support not only helped us make this platform a success, but you have also helped fund SSIA operation to better support this industry. So I hope you have a fruitful and constructive day ahead. Thank you.
Thank you very much, Mr. Ang, for the opening address and also setting the tone for the rest of the day as well. Now let's hear from our guest of honor, Mr. Alvin Tan, Minister of State, Ministry of Trade and Industry, and Ministry of Culture, Community, and Youth, who will be giving his speech virtually.
Mr. Ang Wee Seng, Executive Director, Singapore Semiconductor Industry Association. Distinguished guests, ladies and gentlemen. Good morning. It's my pleasure to welcome you to the SSIA Semiconductor Business Conduct 2022. Now, fueled by new tech applications like 5G, AI, cloud computing, and the Internet of Things, as well as a strong demand for consumer electronics and digital services during the pandemic, we are seeing continued growth, strong growth of our semiconductor industry, both globally and locally. While there are shorter-term risks of disruptions to supplies of raw materials and equipment due to the conflict in Ukraine and lockdowns in China. However, the overall outlook for the industry is very positive. The global market for semiconductors is projected to continue growing to reach $1 trillion over the next decade. And this is more than double the size of the semiconductor market in 2021. In Singapore, semiconductor manufacturing contributes more than 80% of our electronics manufacturing output and 7% of our GDP. Now that's more than the entire information and communication sector or the professional services sector. Semiconductor continues to be the fastest growing segment of the electronics industry, with output projected to increase 30% year on year in 2021. Today, Singapore accounts for 11% of the global semiconductor market, and 20% of global semiconductor equipment is manufactured here in Singapore. Our semiconductor industry is poised for further growth, with around 2,000 more jobs expected to be created in the next 3 to 5 years. As part of Singapore's Manufacturing 2030 vision to become a global business, innovation and talent hub for advanced manufacturing, we aim to anchor frontier investments from global companies with specialized capabilities to support our local manufacturing ecosystem. Singapore has recently attracted investments from leading global semiconductor companies such as Global Foundries, Siltronic, and UMC. Now, these companies invest here in Singapore because of our skilled talent, excellent global connectivity, the ease of doing business, and well-developed semiconductor research and manufacturing ecosystem. In turn, they further drive the growth of our semiconductor industry and contribute greatly to Singapore's R&D ecosystem with high-value activities. Now, over the years, Singapore has also been building our capabilities and capacity in the electronics and semiconductor industry to strengthen the role we play in the global supply chain. JTC has developed 4 wafer fab parks to meet the specific needs of the industry. Now, these wafer fab parks will be rolling out a series of physical enhancements, such as new lifestyle amenities to create a more vibrant and conducive environment for companies and their employees. In addition, JTC is also building Semicon Space in Tampines Wafer Fab Park, which is a new plug-and-play development that will meet the stringent requirements of semiconductor companies, such as vibration-sensitive flooring. The first phase is targeted to be completed this year. Now, as we grow our semiconductor industry, the government will continue working with key industry partners and schools to attract more locals to join the manufacturing sector. We will also ensure that our workers have the right skills to benefit from the opportunities in the sector. In March this year, we launched the M2030 Careers Initiative, Manufacturing 2030, to support companies to develop attractive career options in manufacturing and make these jobs even more accessible to locals. And we are working closely with the team at SSIA on the measures under this initiative. Now, SPITA, which is Singapore Precision Engineering and Technology Association, will work with partners like SSIA and institutes of higher learnings to develop the Manufacturing Employer Handbook to help companies develop structured career progression pathways for their employees. We will also partner SSIA and companies to offer high-quality internship opportunities for students from the Institute of Technical Education, ITE, to spark their interest in joining the manufacturing sector. Now, another major priority as we grow the semiconductor industry is sustainability. The semiconductor industry plays a critical role in Singapore's green transformation. Information and computing technology are projected to consume up to 20% of global energy demand by 2030, with chip manufacturing accounting for most of its carbon footprint. Now, as an industry, we can collectively make an impact on climate change. We must therefore take decisive and concerted actions to embrace sustainability and to drive change. Now, this green transformation also presents exciting economic opportunities for semiconductor companies. Companies that are able to reinvent themselves to harness sustainability as a competitive edge can become more efficient, reduce costs, and better meet their shareholders' and customers' expectations. And the government will support companies on this journey towards more sustainable practices. How? Well, under the Urban Solutions and Sustainability domain of our $25 billion Research, Innovation and Enterprise 2025 plan, we will support the development and commercialization of sustainability solutions. And then under the green economy pillar of our Singapore Green Plan 2030, we aim to strengthen global and regional partners to conduct research and development in green technologies. Now, to remain globally competitive and to seize opportunities in the global semiconductor supply chains, it will help for companies to come together to seek out new business opportunities. They must also collaborate with suppliers and partners to develop and adopt innovative solutions to become even more efficient, productive, and sustainable. And Semiconductor Business Connect was introduced last year to strengthen and to grow Singapore's semiconductor ecosystem by fostering collaboration and then facilitating innovation across our industry. The inaugural Business Collect facilitated close to 30 business connections, and I'm more than confident that this year's event will be even more successful because participants can now come together face-to-face to conduct business networking. I'm also pleased to also hear that SSIA is expanding its secretariat to better support the semiconductor industry's growth and expansion into the region. And this will provide new impetus to our efforts to help our local companies grow, develop their workforce, and to achieve the sustainability goals. In conclusion, let me reiterate that the government stands committed to continue growing our electronics semiconductor industry. And we will work hand in hand with our partners and companies to bring us closer to realizing our Manufacturing 2030 vision. I wish I could be there in person with you, but I'm traveling to Mexico. But I know that all of you are in good hands with Wee Sing and the SSIA team. And I hope to see you in person soon. But meanwhile, I'd like to wish all participants and my SSIA family a fruitful day ahead. And I hope that you will continue to explore new partnerships, ideas, innovations at today's Semiconductor Business Connect 2022. Thank you.
Thank you very much, Minister. Now, in this morning's session, we will explore thought leadership sharing on semiconductor industry trends. Our first speaker today is Mr. Bo Huang, Expert Associate Partner, McKinsey & Company, who will be sharing on the topic of strategies to lead in the semiconductor world. Please join me to welcome Mr. Bo Huang on stage.
Restless, I would like to walk on stage. My name is Bo. I am associate partner from McKinsey, Singapore. Been with the company for 10 years. I also lead the semiconductor electronics practice from Southeast Asia. For those who may have heard McKinsey for the first time, McKinsey is a leading consulting company. We serve about 70% of the top 30 semiconductor companies globally, right, at the global level on various topics, including strategy, sustainability, Industry 4.0, operation transformation, etc. Today, I would like to talk a little bit more broadly on, despite of the fact that, the strong growth that we have seen, what are the challenges that the semicon industry have experienced, and what are the 4, 5, or 6 things that we need to focus to better position us to have a plan for success. I'm glad that Alvin Tan Mr. Minister has given us the numbers. I can skip many few pages. I don't need to touch the market trends. The big message is the following. The industry has really grown fast, And it is an attractive sector from a shareholder return perspective, right? Despite of this, we still face significant challenges behind the scene. Many of the semiconductor players, like leaders, you guys here, may be well versed on the challenges we face. Number one, demand outstrips supply, right? We are still coping with various challenges, including longer lead time, right? So this is hitting many of the headlines, all right? Automotive makers are cutting their production. Increased design complexity. It's good news as well as, not so great news, given that the challenge, the manpower needed to get a chip produced and designed takes longer and requires higher level of talent. Talent shortage, global supply chain disruption, value chain disruption. Some of the large technology companies, automotive, OEM now start to get into the semicon chip design space, right? What does that mean for our industry? What we want to share today, hopefully this will sort of bring some thought, sort of food for thoughts, are 6 things that we think companies should consider when it comes down to design a plan going forward. Number 1, technology leadership. How do we think about technology leadership broadly? Number 2, long-term investment. 3, supply chain resilience, right? COVID is over, but it doesn't mean that the supply chain disruption risk is getting any smaller. How do we think about a supply chain of the future? Talent, right? This is rarely discussed in semicon roundtable, so to speak, and I also don't see a lot of our HR leads in the audience as well. I would like to delve a little bit into the talent pipeline, right? Semicon is not leading. How do we then play the catch-up game better? Collaboration in ecosystem. This is what this Business Connect meeting is. What are the types of collaboration models that we should consider in Singapore setting and greater capacity? Very quickly on the global shortage, right? Semiconductor industry has really gone much more consolidated, right? So there is this index that measures, called HHI, that measure the market concentration, right? So what it means is, I don't need to go into the explanation, right? What it really means is that the higher it is, the more concentrated it is, right? So you can see here, I think the mark in the foundry is the first line, followed by the wafer and equipment. Obviously, the industry in the past 20 years have gone even more concentrated. Now, we also understand, right, despite the fact that there are regional hubs, not a single region is able to have a self-sufficient system end-to-end, right? All the way from design to equipments to material to front end, back end, right? So we are still living in a world where we needed global supply chain, despite of the push for regionalization. It's not over, right? We are still going to be in this world. Chip shortage beyond COVID-19, right? What could be the reason? Number 1, there's a stronger semiconductor demand, right? Picked up by consumer, picked up by IoT, as Minister Tan mentioned also. This is good news. There's also a tremendous digitization speed boost across the world, plus what we call a bullwhip effect, right? This is where many of our semiconductor players are already producing at capacity. A slight small change in the demand would cause ripple effect, right? So the chip shortage is not going to go away this year, maybe mid next year. As you can see here, many of the device types are also experiencing much longer lead time. And this is the data we've captured Q3 last year. And I don't think the picture has improved significantly per se. Many of the devices still suffer a lead time up to 6 months. Broadly, folks are talking about capacity expansion. This can be a bit of a political debate, right? You can see here many of the countries are putting dollars on the table. Let's don't forget, investing in leading edge is not the only solution, right? We can see here that the black is the demand, the blue is the supply, right? So there is that discrepancy happens primarily in the leading edge, as well as the mature node, right? 22 to 65 nanometer. Now, the question is, what does that mean to the semicon players? Going forward, we believe that there's a substantial shortage for 22 to 65, and this has happened to be the nodes that the automotive guys are looking for. Those shortages will ease off slowly as structural perspective improves, right? For example, the stock replenish is going to happen. And we think that there is a, it takes much longer time for systematic recovery for the capacity. I'll explain to you guys in a bit on, despite of the challenges, what are the things that we should still consider doing to devise the success plan. 6 ingredients for success, right? I'll go down there, 6 elements, right? Number 1, technology. If you take a step back, looking at the R&D research share by the revenue, compare across different sectors, non-surprisingly, semiconductor is only secondary to pharmaceutical and biotech, right? So it's close to 14–15%, right? So many of the companies, they have the profit gain to reinvest in R&D. That's good news for all of us. Where should we think that the investment should go? We think that broadly there are 4 themes here. Number 1, leading edge, right? No discussion, right? Folks are knowing that because of the computing intensive applications, there's a clear focus on leading edge. Now, obviously, the ecosystem is, if you have solutions that enable process control, yield improvement, as well as monitoring, then you have a game, right? This is where the R&D focus could focus on. Second element, more than more. So let's focus less on the silicon, but more on the alternative materials. So a few examples could include the silicon carbide or GaN, or gallium nitride, right? Those are the new materials that we see that there's a significant growth prospect, right? In a CAGR of 30 to 40% in coming 5 years as alternative material, especially in the era of saving power consumption, etc. Advanced packaging, right? And sitting in this part of the world, that we are the center of packaging, right? APAC represents 2/3 of all the back-end packaging. Investing in the technology that enables advanced packaging as an ecosystem, not as an individual player, right? Lastly is a specialized application, for example, application-specific IC or ASICs, right? These have opportunities for smaller companies, right? You guys have a chance to be developing a specialized customized solution. As I said, the leading edge migration, right? So sort of we did a bit of a mapping, right, across different devices, right, from memory, micro component, logic, and sensors. As much as the world may not understand clearly, there's just a migration only happens in pockets of opportunity, right? So these migration primarily focus on micro component logic, and this is where the leading edge pushes are. The large share, the overall demand remain feature nodes, right? As I mentioned also, the GaN power devices and silicon carbide power devices are our projection in the next 5 years with 3 different scenarios, right? There's upside, there's a base scenario, conservative. We still see, you know, in the high billions of opportunity for alternative materials. Alternative advanced packaging, right? As I mentioned, traditional packaging, the share of traditional packaging now is about 60%. We see it's going to come to maybe half, maybe 40% in the next 5 to 6 years. Given the requirement, the miniaturization of the IC devices, as well as some of the foundries are also getting into the space of advanced packaging. Right? This is where we see the trend is coming. Without going to the details, right, you have fan out, fan in, and stacking. Especially on the stacking, right, is representing the highest growth, right? We projected about 25% CAGR in the next 5 years. Success recipe number 2, long-term R&D investment. The key message is the following. Many of the investors are skeptical about committing dollars on the semiconductor companies. However, the case example or the history has shown us that companies who are committed to putting R&D dollars, especially on long-term investment, could pay off, right? So two examples here, SML and ARM. The EUV litho, right? This has been the most crucial technology for leading edge, front-end fabrication. ASML spent 17 years, right? Committed about $7 billion to get this work. And now this becoming a dominant revenue of this company. Similarly for ARM, right? They spent 6 years to develop a 64-bit processor, right? That allows them to become the key player in this space, right? So what is the key message is semiconductor companies focusing to invest areas that they're familiar with, and they're willing to commit long-term investment. Success recipe number 3, supply chain resilience, right? So post-pandemic will still remain very volatile. And this requires companies to start looking into their supply chain to say, how do I build resilience, right? I'll come back to that in a bit on what does resilience really mean. What are the fabrics that a company needs to build for supply chain resilience, right? These are some of the examples that the company are already doing, right? For example, you script the supply, you establish multi-tier supply chain transparency, expand supplier base, strengthening your price strategy, steer your customer demand, invite your customer to co-invest and develop customized chips, revising down payment policy, and require customer to commit long-term demand, right? These are the tactical things many of the companies are doing to cope and build more resilience in the supply chain. Where do we see the future generation of supply chain? Broadly, 3 themes here, right? Number 1, as I mentioned, building resilience to tackle the market volatility. And how do I actually create a event-driven disruption? I have a coping mechanism. I have an early warning mechanism, right? So this is resilience. Digitization, right? This has actually been talked about quite a bit. Now it becomes real when it comes down to supply chain. Much of the digitization work is at the shop floor. Folks are looking at increased connectivity, right? End-to-end, going down to the next tier of the suppliers, and sustainability, right? So that links to the consumers, to your customers, regulators, as well as your four-wall factory. How do you think about reduce your green house emission, right, profile? We have recently, McKinsey as an institution, we have recently developed a supply chain resilience index, and I think we've worked with some of our colleagues here, also have conducted the initial assessment. I wanted to take some time to sort of give you a rough idea of what this index is all about, right? Supply chain risk, we think that there are 7 areas, right, without going to all details, right? The financial, the regulatory, the data security, the structural, organization, reputation, as well as operational risks. Supply chain resilience, right? It boils down to 4 things. How is our supply chain risk being managed? What is the process? Do we have the process in place? Do we have the digital infrastructure that allow us to capture the data and assess the risk? Do we have the right governance, right? The organization setup. What is the incentive for risk management? Lastly is capability. Do we have the right capacity, talent, the knowledge to assess and manage and mitigate risk? So use this lens that we have developed the 7 aspects across these 4 dimensions. And this is a rough output of such assessment where it allows you to sort of position your company versus your peers and gives you an indication on where the opportunities are. And we're also in the process of stringing together semiconductor sector insights, and hopefully As time goes in the next couple of months, we should be able to help to publish that part of the data. We think we'll connect offline on giving you guys a debrief on that front. Okay, so I wanted to spend a bit of time on the talent. I also know that some of the subsequent talks are also on talent. The subsequent reports are not very complementary to semiconductor sector, right, for a few good reasons. This has been largely ignored. We are in a disadvantageous position from a semicon talent attraction perspective. 3 challenges. Talent acquisition, very competitive, especially when it comes down to technical capability. In a very highly competitive market, the tech talent retention is crucial, right? So the big attrition, we are facing an uphill challenge, right? Across industries, operational health, right? Your organization health is also a predictor for your financial performance. And semiconductor is falling behind to our industry peers. And this is the, obviously, as I mentioned, right, as our node goes more advanced, the time and the money spent or the manpower needed to develop and produce has gone exponentially. So that puts even more pressure for us to hire right, hire more. This is coming from Glassdoor, right? We compare our sector, semicon companies, to tech companies, automotive companies, right? So you have the 3 bars here. Semi is the on the left, the black is the tech, and the bright blue is the automotive. Across all dimension, we are not perceived as attractive to the other industry, right? Glassdoor, public data. If you take a step back, a few other observations sort of help to highlight how can we make our semicon industry even more attractive to talents. In the only Intel, right, has been ranked as top 50, the most attractive employees for engineering and IT. This is globally, right? For US, right? So in NVIDIA, TI, and Qualcomm have been the only semicon that rank as the best place. If you take it to Singapore setting, right? So yesterday I did a bit of a research by looking at the most attractive places the engineering and natural sciences students in Singapore would like to work. Here are the top 5 or 6 choices, right? You have A-Star, Google, Apple, GSK, ST Engineering, right? I can't find many semicon companies in that top 50 among the STEM students, right? So there is a fundamental disconnect. Why could it be? It could be a brand awareness, right? As semicon companies, we haven't built enough strong brand to attract good talents. It could be also a resource attractiveness. Do we getting a competitive, pay for comparable talents, right? Broadly speaking, there's also an element, I'm going to skip this. As I mentioned, the organization health is a strong indication for financial performance. We have compared semiconductor industry versus the similar industrial space, right? So among many dimensions that we are falling behind, in particular, talent acquisition and talent development, right? This is one of the organization health survey that McKinsey has. We're happy to share a little bit more on how do we fix it, right? So broadly, what does that mean? A few messages, right? In semiconductor industry, we needed to have a bit more structured approach to think about how we want to cultivate, how we want to build the talent pipeline differently, right? So there are 20 dimensions to assess whether the company has the right ability to attract, to retain the right employee, to give the right experience, right? You could actually use these 20 dimensions and benchmark it against where you stand versus your sector leaders. That will help you to prioritize how to rebuild the talent acquisition system, right? All the materials will be shared to you guys and happy to discuss with you guys offline as well. Very quickly, I'm going to move on to recipe number 5, partnership. There are a few models that we have seen in the ecosystem, how the collaboration happened, right? Partnership with customer, that's, some of the examples would include automotive OEM. They have already partnered with semicon companies on application, specific applications. Players develop IP, right? That many customers can leverage. Programmatic merger and acquisition, right? This is also an interesting and emerging theme that we have seen in semi world, given that the industry is coming onto a more consolidated space. Industry association and academic institutions, right? As Minister Dan also mentioned, this is a crucial element to foster better road mapping, as well as the working with research institutions, right, to cultivate the next generation of talent. And of course, between industry players, there are joint effort to target capacity run and gain productivity, right? So, there are very emerging new ways of building collaboration across the ecosystem. Very lastly, success number 6, right? As I mentioned, capacity expansion. McKinsey has recently published an article talking about fab construction, right? As we are going through the exponential growth, right? Many of the new investments are coming in. From a global perspective, what will be the optimal fab size that will achieve the best cost positioning, right? So our view is there's a sweet spot, right? If you have a fab capacity expansion of approximately 600,000 layer LSPW, you will generate the best cost position, right? Again, this is purely by analysis. Of course, it's driven by the local cost positioning, right? So this will give you a bit of a sense on how you can construct high capex investment, ensuring your best optimal return. I'm going to wrap up my talk by sort of a refresh on the 6 lessons or 6 recipe for success. How do you think about technology leadership as the ecosystem players? How do you want to be part of the technology advancement? Long-term investment in R&D, where should you put your money on, given that the short-term return may not be possible? How do you build supply chain resilience? How do you actually refresh your talent pipeline? Because talent would position you for long-term success. And what are the new ways that you can collaborate in the ecosystem? And how do you think about expanding your capacity differently? Okay. With this, I would like to give thanks to SSIA for inviting us for giving a talk, and happy to connect with you guys offline on any of topic of interest. Thank you.
Thank you very much, Mr. Huang. Coming up next, let's explore emerging opportunities in fab equipment component supply chain. We're welcoming our next speaker, Mr. George Alajajian. He's the Vice President, Strategic Parts Supply Chain of Intel Corporation. Now, as he's unable to join us in person, he will be doing his presentation virtually as well. So please enjoy.
Good morning, ladies and gentlemen. Minister Tan, Mr. Ang, it's really exciting to be in a meeting with you and presenting emerging opportunities in a fab equipment component supply chain. I wanted to be physically present there, but I couldn't just before taking my trip. I've been tested COVID positive, so I declined to fly and connecting you with a video. So today's topic I would like to share with you is very dear to us, and I would like to spend the next 20 minutes to share with you the great opportunities we have in front of us. I want to do this one just focusing on last year and understanding our environment. We all still living the COVID supply chain difficulties and challenges in front of us. Just about a day ago, I was talking to one of our suppliers, the CEO of a large surface technology company, and he was telling us their his Shanghai facility is not operating full speed because of the Shanghai shutdown, and he had to pre-announce his earnings less than $30 million for this quarter. You all heard about chip shortages. Chips for chips. Component manufacturers need to have chips to manufacture controllers. Controllers manufacturers need to have the controllers to manufacture assemblies. OEM equipment suppliers need to have assemblies to manufacture OEM equipment, and the fabs need the OEM equipment to manufacture chips. This will continue for a while. Shipping and the long lead times in front of us. Try to buy some elastomers or O-rings. Used to be about 3 months lead time. Now you cannot get some of these components more than a 12 months to 18 months time frame. Same with other materials. Try to buy a plastic like Vespel. Vespel lead times increased from typically 3 months, now it's about 6 months. We will continue our geopolitical tension in Russia and Ukraine war, and we have not unpacked all the supply chain challenges related to this. People talk about neon, gas shortages, talk about fluoropolymers that are being sourced mostly in Russia. It's going to create another wave of shortages in elastomers. Labor shortages will continue. The talent war is big, it's there. I was in a taxi driving from an Intel office in San Jose to San Jose Airport. Every other building had a big banner on it saying, "We are hiring engineers. We're hiring technicians." This talent war, shortage of the labor, shortage of a talent will continue. It's not only in Silicon Valley, it's all over the United States. In Europe, we have shortages in Ireland, in Israel. We have huge supply chain challenges. We are all learning how to live with it, and we are learning how to manage this. But the biggest challenge which we have in front of us is the entering a very, very massive investment era of a semiconductor and semiconductor infrastructure. Let me go details of this one. The entire world is becoming digital. We know about the omnipresent computing, connectivity, cloud and edge infrastructure, artificial intelligence is all around us. Semiconductors are underlying technology empowering developers and powering our customers and innovation. The entire world runs into silicon. Just the forecast of a semi forecast shows by 2025, fab will produce over $700 billion of semiconductors. Capital spending at the time will be $145 billion. I think we can even reach the $145 billion this year if the capital OEM manufacturers will be able to deliver, because some of the delivery lead times are more than a year for some deposition products. And what's more interesting and is important than when you look at the 300 millimeter wafer manufacturing capacity for 2025, for the all advanced nodes, it's going to grow. It's going to grow more than 60%. So the world is running on silicon. And what the world is trying to silicon, Intel answer to this one to capture this, the growth of the market. Intel announced a mega expansion for the next 3 to 5 years. If you will sit down and calculate all the announcements we announced more than $150 to $180 billion investment in fabs. We announced the Oregon investment, increase of our D1 expansion in Ireland, Israel, Arizona. We just announced mega structure fabs in Ohio that will be in 2025, as well our investments in Europe, in Germany, France, and Italy. It's not only the front-end fabs, but also announcement increasing our capacity and footprint in advanced packaging in New Mexico, assembly and test in Costa Rica, and significant large footprint increases in assembly test area in Penang in Malaysia. Let me go and try to share with you some forecast of semiconductor equipment sales. In this chart, you see the forecast that's coming from a VLSI research shows that the semiconductor equipment sales will grow over 250 billion by 2035. If you look at the different 3 years growth path, you will see the semi-equipment sales will grow about 10 to 12% of CAGR, depend which years you're looking. But what's important is not only the semiconductor equipment growth, but explosive growth that this creates around the components, because every semiconductor equipment that we put in a fab requires spares and the components to operate. So we have two factors here for this explosive growth. One factor is the wave of a growing capacity. The other one is the application and usage of the spares and the components because of the highest and the better technology nodes. You see, every time we go from one tech node to more advanced nodes, our investment on a capital equipment growth will be about 50 to 60%. Well, the investment in spares and the components will be significantly larger. Semiconductor growth drives a full ecosystem and demand. Let me take the next steps and double click some of the spares as well as the component side of the business. This is a chart I borrowed from my friend John West from VLSI. He presented early 2020 the size of the component market. Actually, he talked about 3 different applications of the spares and components. One side, device makers, they consume about 40% of the components. In 2020, he estimated this market to be around $8 billion. OEMs, equipment manufacturers, meanwhile, buy these components to build their equipment, which they're estimated to be about $7.5 billion. While during the service, when you do PM or maintenance, you also use some of the spares and the components. This being estimated in 2020 to be about a $4.5 to $4.6 billion. This is a huge market. This is a $20 billion in 2020. And our estimation shows this market is growing much faster than any other sector of the equipment business. Our estimation, this market is growing over 10 to 20%, 10 to 12% year over year. Our estimation for this year, this market will be about a $25 to $26 billion. On the right-hand side of the chart, you also see our spending by component, by commodities, vacuum, optical, ceramics. Some of this consumption of these components are there for a long time. You don't replace the vacuum pumps too often. You don't replace the robotics too often, or some optical components, but there are a lot of components inside the chamber and a plasma that's getting plasma exposure that you have to, that we call them a critical components that you have to change it much faster. In Intel, we'll look at this one differently. We'll look at the by category that the parts that we use during the supporting of our fabs. 20 to 25% of our parts are silicon based. Well, the elastomers, seals do represent between 10 to 20%. Electrostatic chucks between 10 to 15%. Vacuum components 10 to 25%. So Having these components in our industry in supporting the fabs, we always look at the three different levers. First, we see if these components could be cleaned, could we apply surface technology. Secondly, we'll look at this one if we can repair and refurbish some of these parts. We cannot clean it, we cannot surface treat, we cannot repair it, we have to use a new one. This is a great opportunity to play across several commodities here. So I'm going to talk about the first opportunity in front of us. It's an opportunity that connects to our engagement model. Typical engagement model, OEMs work with the component suppliers, they work with the material suppliers and service providers. They implement the solutions into their OEM equipment, and they create the solutions that are one size fits all for all IDMs, for all foundries, for all memory fabs. But yet, there's always a differentiated section of the spares and the materials and services the fabs and IDMs and memory fabs need. Not all the fabs are being created equal. So what we are looking, differentiated solutions to have our component and the material suppliers directly engage with us, create differentiated solutions that are unique for our specific processes and specific applications. So one opportunity that I want you to take from this meeting, that there is a great opportunity for you to directly engage with fabs, directly engage with the foundry business, with memory manufacturers, instead of going through OEMs. Second one, which is a probably bigger and a larger opportunity, is the scale. We talk about this explosive growth of the industry that's in front of us. Scaling is the key to our success. Scaling does not mean adding a footprint. It's not about having more fabs and more footprint. It's about improving the quality. It's reducing the waste. It's not only adding more, but also taking out what's not adding a value to our fabs. When we look at the scaling, we look at the fab customers and ask them, what is that we want from our suppliers? Where we want our suppliers to scale? First of all, technology solutions, execution velocity, and the cost of ownership. Three vectors are super important for us, for our suppliers to expand and scale. I will not spend too much time talking about the technical needs for it, but in advanced materials, we're looking high performance and yield improvements, chemical compatibility, high purity material, and very good novel ceramics. In surface treatment area, we're looking for conformal coatings, very low defectivity, and multiple cleans and recoat. Material innovations needed to address end customer needs. In terms of velocity, we're looking very fast R&D, get quick design wins, develop scalable technologies, localized solutions, have a local presence and close to R&D, work with R&D engineers, be very close to manufacturing, understand their needs, and deliver these things on a timely manner. But what's really close to my heart is the fab support. How fast we can turn around these parts, how we can create a return value chain and maximize the return and do best inventory management. In an area of the cost of ownership, we're looking better performance in terms of higher yield, lower defects, high quality, and great aftermarket support. Of course, lifetime is very, very important for the parts. Meantime between clean and replacement, understanding root cause failures and fixing it, and making a data-centric decisions. Scaling, again, is not adding footprint, but trying to repair the parts rather than buying a new one. Try to clean it, recode it, and apply some surface technology solutions. Selection and based on a performance, our selection for the spares are based on a performance and the total cost of ownership. At the end, then the opportunity is a great opportunity for us to enable the fabs by partnering with fabs and the customers and meeting technology velocity and the cost of ownership requirements. This concludes my presentation. Thank you very much for your time. If you have any questions, please, I will not be around during the break time, but we have Helen Wang. She is the director of our strategic parts supply chain in Singapore and manages our procurement and supply chain activities entire Asia. We decided her position to be in Singapore because we feel Singapore is the center, is a cornerstone of our supply chain and the hub to be managed the supply chain. Please connect to her and ask any questions that you're interested in. We'll get back to you. Thank you very much.
Thank you so much, George, and for being such a trooper and tuning in despite having COVID. And of course, we wish him all the best in his recovery journey. Now, ladies and gentlemen, we'll now take a 30 minutes tea break. So during this time, you can use it to network and also visit the exhibition booths. So I'll see you back here shortly at 10:40 a.m. Welcome back, ladies and gentlemen. I hope that you've enjoyed your tea break. Now let's dive straight back into our program. Our next speaker is Mr. Ganesh Prasad, Director, Product Marketing, Wedge Bond Business Unit, Kulik and Sofa Private Limited, who will be talking about solutions enabling the automotive industry. I'll hand the time over now to Mr. Prasad.
Check. Good morning. I hope I'm loud and clear. So after a short break, good to see you all. And I'm glad I'm back here because I was part of the Leadership Accelerator program from SSIA. So it's nice to be here. And I see some of my classmates and cohorts as well here. Good morning, and I would at the outset like to thank SSIA for providing this opportunity to speak in this prestigious platform. I'll be talking about solutions enabling automotive industry. So without much ado. So typically from the outset of the 19th century when automobile development and introduction started off, there were a few characteristics that went into an automobile. Convenience, basically for transporting people from one place to the other. We were talking of efficiency. So once the convenience came in, the next thing that crept in was efficiency. How can I do this cost effective? How can I do certain things in terms of performance? Safety became another utmost important element overall, right? So these three things were the main elements which were there in the earlier part of an automobile introduction. But off late, and as the entire transition and transformation started off, we started seeing a lot more technology that is going in. And now technology is one of the characteristics that is needed in an automobile. And as you can see every day, with the transition from an IC engine to a hybrid to an electric vehicle, there's more and more technology that goes in, and to the extent the next generation of autonomous driving as well. So how does a futuristic car look like? Just to keep everybody interested, perhaps something like this. So there's a lot more components that are going in. And now, what does this mean to us? basically, in terms of an automobile having so many electronic components, right? So that means there's a lot more semiconductor that is needed, right? And this has been backed up by some data that we got from Prismark. As you can see, it's a busy chart, but let me summarize what exactly this is. The general trend, if you look at the bar graphs that are there at the bottom, shows that it is climbing. That means the amount of components that are going into automobile is increasing in general. And if you look at the extreme top, there is a summation of how much of electronic components that are going into an automobile, right? So even though we had the supply chain disruption, we had pandemic and so forth, there is this trend that is continuing on, and then it will continue as we go into the next generation of electrification and so forth. So in short, electronics and semiconductor content are increasing, and with this advancement, the automobile industry is also evolving, and this technology is really something crucial. Now, with so much of technology in, how do I piece this and present it to you guys was a big challenge. So we thought, of course, there are different ways of presenting this information, but I thought maybe it would be interesting if I broadly classify them into two elements. One is in terms of energy management. So if you look at any automobile today, the amount of electronics that goes in, definitely there needs to be energy management. The amount of transition, or the pace with which a transition is happening in terms of IC engine to electrification, definitely power management is something that is critical. Lighting has also evolved significantly from a halogen light to a LED light, and I have a couple of slides talking about that. More so on the power management and the lighting, there's also another element that is coming in, which is in terms of the artificial intelligence that is being built in, be it in terms of ADAS, be it in terms of safety systems, be it in terms of infotainment. So you get into an automobile today, it looks like a gadget. It no longer looks like a boring automobile, which is to be driven from place A to place B. That is how things are evolving. And every single component, as you add on, there is semiconductor that is going in. So that is actually our bread and butter for most of the people in this room. So let me deep dive a little bit into what we see in terms of the in terms of the electronic industry, or the automobile industry, for the energy management part of it, and specifically going into an automobile. So if you look at an automobile today, the bigger skeleton that you see is an electric vehicle, and the insert at the top is what you see for a internal combustion engine. There are many components. So we start off with a battery pack management. There could be drivers that control the motors that are driving and controlling the car. There are voltage converters that are there, charging elements that are there. So there's so much of control systems that are going in, which all involves components and semiconductor. If I take a step or two back and look into the IC industry, right, or IC engine car, there is also stop-start. So you might have seen the stop-start components or modules. Engine management, there's a lot more data that is being also presented to the dashboard. Ignition systems, safety sensors, your car belt is snapped on, yes, no, there are sensors, parking sensors, and so on and so forth. So there's a lot of these things that are coming in terms of electronics. Electronics also has evolved in terms of the power devices that are going in a historical trend. To what you see on the left hand side are the discrete components. So it was being planted onto a PCB, and then the whole circuit was providing solutions. And of late, there are intelligent modules, or the power modules, that are coming in together, where more and more electronics are being assembled into a module, or what we call as a power module, and that is enabling the automobile industry. In addition to this into the power module, there's a lot more transition that is happening even in terms of the silicon that is being used. So earlier on, we heard one of the speakers mentioning about the transition from silicon to silicon carbide or gallium nitride. So this is one example that I am trying to highlight. With the same footprint, people are trying to transition from silicon to silicon carbide, and the performance of those automobiles is is going multi-fold. So there is, when it comes in terms of the operating temperature, the extreme temperatures where these need to operate, the compactness that needs to be there, because we do not want to have a bigger, footprint for all these power devices, and so forth, right? So the higher voltage requirement in automobiles and stuff like that. So with silicon carbide, we see it's transforming and transitioning the automobile industry. And of course, if you look at the graph on the right top, it's not just in the automobile industry, but in any sector where there is semiconductor that is going in. But let's focus only on the automobile industry in the interest of the subject. What's happening inside the components? If you look into it, there is wire bonding or wire interconnect, aluminum wire typically, that is what is being used. And as the packages evolve, this, the cross section of these interconnects are changing from wire to ribbon, right? But the semiconductor is still the silicon based semiconductor. However, with the silicon carbide coming in, all else equal, again, the customers or the manufacturers are able to get a better throughput or output from the same footprint of a product, right? And there are also innovations that are going into the interconnect space as well. So it's not just aluminum that is being used in terms of interconnection. People are looking at something that could be a hybrid. So it's like a copper at the core and aluminum at the peripheral. So this saves a lot more in the transition phase, because the metallization on the semiconductor need not be transitioned or transformed. So this is one example where the performance of the semiconductor or the overall solution that is being provided is being improved and enhanced. And this is all because there's a demand with the transition we are seeing in the automobile industry. We have also seen that off late there are a lot more people looking into copper coming in to the interconnect land space, especially when it comes to power management. The main reason again is because of the performance compared to aluminum. That's the basic physics over there. However, there are concerns in terms of the semiconductor availability. Metallization on copper is not that easy, but there is this development that is happening, and we are lucky and fortunate to be in this era where this transition is happening as well. So these are some of the developments and trends that are happening, and this is a critical element as far as the power management elements of an automobile is concerned. As there is more and more intelligence that is being added in, these modules and these elements keep evolving, and that really is something that keeps us all exciting, right? Another element in the power module segment again would be on the passive surfaces. As much as we talk about the semiconductor, there's also the passive surfaces where there's a transition that is happening from a wire bond all the way to a copper interconnect through ultrasonic interconnect technology over there. So with that, the coefficient of thermal expansion is more or less standardized or uniform, and the performance overall for a power module product would be much better. So this was a snippet on how the evolution is happening and enabling the automobile industry in terms of a power module. Now I want to switch gears into the lighting, right? So most of us have seen a lighting on an automobile. Typically in the past, it was all halogen light, and off late, light on the headlamps on an automobile is changing into LED, and it's becoming much more sleek. And there's a lot more things that are being added in. It could be the same light that is used for indication to turn left or right, and so forth. There's also a lot more development that is happening in terms of adaptive driving beam to enable the same light set to dip and dim your lights, make sure there is no glare. And also there are elements that are being added in terms of dynamic bending, or it could be in terms of a marker light to ensure when a poorly lit road when you're driving, there's a better visibility of certain specifics that you would like to have. So with all these things happening, what is it that is needed in the whole industry is the demand on these LED assemblies and placements. So this traditional surface mount technology that is being used has to be adapted to make sure that these LED are being assembled and introduced into the automobile appropriately. So there needs to be prevention of self-alignment. Most of you know that when it goes through a reflow process, there could be a disturbance in the overall alignment of this lighting, and that could have its own repercussions. Binning is another terminology that is used in the LED industry, where you try to, I mean, in simple terms, group LEDs that are performing with a given input in energy. The output performance is more or less similar, if not the same. So if binning and alignment of lighting is not taken care, and that could have an impact in terms of how the performance of this lighting could be, right? So it could be very unpleasant for a person who's driving an automobile or facing a car that is coming across. So these are some of the elements. And again, these are evolutions that are happening, and it's very exciting and an interesting time phase in the automobile industry. Switching gears over here, let's talk a little bit about the artificial intelligence. So as what I mentioned earlier, when you step into an automobile today, it looks more like a gadget rather than a vehicle. And as you see there, every single element. So in the past, you had indicators, physical indicators showing the speed, the speedometer basically, or the fuel, how much fuel is remaining. All these are digitized right now. You had audio systems, you had other controls. All these are being transformed into touch screens and technologies that are going in. So as you see the complexity of the technology that is there when you sit into a driver's seat or the passenger seat, all these are not of a same form factor. The form factors are different and odd shape, right? So flexibility is one thing that is very, very important, and that is what enables this infotainment cluster. We also see that in terms of the quality. So with all these things that are happening, so the same quality has to be in place, right? So as you start assembling a dashboard electronics to user interface electronics in an automobile, with all the variations that are coming in the odd form factors, multiple products, flexibility is very important. At the same time, there's no compromise that would be accepted in terms of quality. So you could expect a high yield in the first pass. You also try to minimize, if not eliminate, the scrap. And most important, there's a lot more traceability and the warranty management that's all going in, right? So I think the quality and the process flexibility are very crucial whenever you're manufacturing the infotainment and instrument cluster that are there in an automobile, right? It can be gone in further to explain what are the requirements, but in the interest in time, I would perhaps leave it here and then move on. The next one that is coming in is also equally interesting: the cameras that are going into an automobile, right? So nowadays, if you look at the cameras that are being adopted, it's again for making sure that there is a better visibility, better data, and based on those data, when it goes into autonomous driving and so forth, there's a lot more processing that could be done, right? So, and as we see in the bottom right graph, the number of cameras that are going into an automobile is almost very similar to a mobile phone in the coming years or already at this point in time. There are different ways of supporting the sensors and sensor mounting over there, but in the general scheme of thoughts, this is what we see in terms of the camera adoption in an automobile. And that's again enabling the upcoming trend and technology. Skipping again to another element, right? The sensors and the infotainment elements that we saw over there. So all along, they were all being bonded with gold wire. There has been of late an adoption of copper into all these elements. Although automobile industry is late in adopting copper to some extent, All these things were there in the memory and the IC market. It's already gone through. So that's the benefit that the automobile industry would be getting, or the automobile elements would be getting in, because the learnings that were there from the IC industry in terms of copper adoption can all be fanned in over here. And it could also help in accelerating the whole process of the package development and trend. As we move further, the next element that is coming into the consideration here is the overall manufacturing process. So when you look into the manufacturing process of these components, this buzzword in the industry that everybody is looking at, zero defects. So everybody would want to make sure that the return on investment is maximum, and they minimize the overall defect. So that gives the reliability, peaceful sleep in the night. So as you see, there's a lot of data that is being archived at this point in time. There's predictive analytics that is being introduced into the whole production process. And at the same time, there needs to be some decisions and actions that need to be taken accordingly. So a lot of data is good, but how do I interpret this data? What do I do with this data? This is very, very important. And a lot of equipment manufacturers and the production lines are right now looking into how do I put these into production, and how do I enable my production to be more efficient and effective, marching towards zero defect. Now with that, actually it comes to what we have been hearing in the industry. People are trying to get into a lights out factory mode. Lights out factory mode is not easy to achieve, but it is not impossible to achieve. So what do you see in this entire episode is that you would need to make sure you have the right elements, like what I mentioned in the previous slide, all the data that is being collected, all the predictive analytics algorithm that is being adapted over there, traceability to be included and incorporated. And that is something that is at this moment happening. And there are a lot more production solution providers who are working with the customers in enabling this. Industry 4.0, we have heard about this multiple places and multiple forums and so forth. So if you look at that again, we have a lot more variables over there in terms of real-time process monitoring, which we mentioned earlier, visualization. So you might also want to have a central control room where you would like to have all this data presented to you in something that you would like to interpret appropriately. Traceability, because I would like to know if I have shipped a part or a product to a customer, how am I able to realize or understand what were the responses for that particular product, if there were any claims, God forbid. Predictive maintenance. So when the production is running 100%, there is no way I can stop the production, and I cannot down the line just because of maintenance. So rather the equipments and the line need to have the intelligence to make sure it can announce these things, and all the data that is being archived overall, that needs to be stored in a cloud so that it can be processed accordingly. We also see people with the recent trend that we are seeing in terms of regionalization of the production. There is also portability. That is another element that is being looked into. So whatever that I am getting with the input variables and whatever the output I'm getting at factory A, I should also be looking at the same output at factory B in another region. And these are some things that are coming. So equipment are also being made, automation friendly. And I think the entire assembly process and the designs of these equipment are enabling this, automation of factories, and also towards, as what I mentioned in the earlier stage, lights out factory kind of an environment. So with that, so we spoke about the energy management elements. We spoke about the trend in terms of artificial intelligence. We also spoke about what factories are doing in terms of, automobile or automotive, manufacturing. So I would like to take the next couple of slides to just market about what Kulik and SOFA is all about. And we do have solutions. We are working with all the customers and partnering with them in enabling the technology. So we do have solutions if it is in terms of the power management, if it is in terms of LED lighting, be it in the infotainment cluster, or be it in terms of the cameras and the CMOS sensors, or factory automation for that matter. So that's basically Kulik and SOFA. We have been in the industry for more than 70 years, starting off with a wire bonding, gold wire bonding, and then expanding ourselves into all this electronic assemblies and advanced packaging. So to conclude my presentation, automobiles are being populated with a lot of technology. It could be in terms of power management, it could be in terms of artificial intelligence. We spoke about all these things. More technology means more electronics, and in turn, more semiconductor. Increased semiconductor, the content that is going in is driving towards innovation in manufacturing, because there's a lot more demand that is coming in as this automotive industry is transitioning and as we march towards zero defect. These innovations that are happening in the manufacturing, this is actually augmenting or complementing and enabling the efficiency, the very first slide where I mentioned about convenience, efficiency and safety part of it. So this is where it comes together, right? And Kulik and SOFA is really excited that we are part of this journey and offering the total solutions to customers in the automobile industry and enabling the solutions over there. So with that, I conclude my presentation, and thank you very much for offering this time.
Thank you so much, Mr. Prasad. So next up, we have Mr. Gian Damayan, Head of Business Development for Industry Energy Southeast Asia, to share with us on the topic of the global energy transition to a sustainable ecosystem.
Good morning, everybody. So I'm very happy to be here today with you. I would like to thank SSIA for the invitation. So my name is Guillaume Darmayan, very good pronunciation of my name. It's very unusual, so thanks for that. So my name is Guillaume Darmayan. I'm leading the development of engine APAC. I'm here to represent Thomas Bodlow, our CEO, which yesterday night has a personal issue and could not make it this morning. So today we are here to talk about sustainability. I'm not a semicon expert, I'm an energy expert, so I'm not going to say how semicon can improve the energy efficiency of cars, of batteries, of solar panels, of wind turbine. No, I'm talking about how your manufacturing plants can be more sustainable and can support the different energy transition which has been started years and years ago. Earlier, we hear from our friend from Intel that this year there was a lot of constraints, such as the chip shortage, the COVID, of course, the supply chain, and many others. I do think that we need to put one more into the picture, the sustainability and the climate change. Let me throw three numbers. So 36.7 degrees. I'm not checking your body temperature here to see if you are positive or negative. This is the temperature that we had last weekend in Singapore, which is the highest temperature that we ever had over the last, in the history of Singapore in the month of May. This is to say that the global warming is not a story that we hear on media, but it's something which happened here in Singapore, everywhere, today, and actually yesterday. 755 billion US. I understand from an earlier presentation that it's more or less the revenue of the market of semicon in the world. This is as well the investment which has been done for the energy transition over in 2021. These figures, according to the IPCC, should increase to 2.1 trillion USD per year from 2022 to 2025 if we want to reach our objectives. The last 29.90, okay, I guess this is a number, unfortunately, that some of you knows very well. That's the price that SP tariff is right now for electricity in Singapore, which has tripled over the last 12 months. And when we know that, you may know the number better than me, but roughly 20 to 30% of your OPEX are related to energy supply, this must have huge consequences for you. So the good news is that the world has made some commitments. I'm not going to describe, and I'm not here to summarize what have been done in the COP26 and so on. I'm here to say that there are some actions ongoing. Singapore has committed, for example, to reduce by 36% by 2030 its carbon footprint. Lawrence Wong has announced for the budget of 2022 the carbon tax that I'm sure you all heard about. In APAC only, 50% of the emissions are, in the world, 50% of the emissions are related to APAC. So we have a huge game to play here. And it will continue to grow. We are one of the regions here which have the biggest growth. So indeed, the emission will keep growing since the economy is still growing in the region at a faster pace than elsewhere in the world. The cooling demand will increase. The urbanization will increase. We hear about 60% of the population living in cities by 2030. That will drive more energy, more constraint, and more CO2. However, the businesses, all of us as business leaders, have a responsibility and has some action that we can take. As of today, there are some surveys which say that 60% of companies in Southeast Asia do not have CO2 commitment. Let's see. Let's zoom in on the manufacturing sector. All right, let's be a little bit honest. If 40% of the GHG in APAC are related to the manufacturing sector, I'm not saying that semiconductor is a large part of it. We all know that oil and gas, most likely heavy duty industries such as cement, steel, glass, all this kind of very carbon intensive businesses are responsible for a very large part of those 40%. However, not 80 companies are in control of the oil and gas and those kind of heavy industries in APAC, which is the case of Semiconductor. If we look at the past and the future, it's interesting to note that if we want to reach the objective that has been collectively agreed over the Paris Agreement and in Glasgow, we know that we have to decrease by 1.8, we have to decrease by around 5%, sorry, the emissions over the next few years until 2030. 5% reduction, knowing that over the last decade, we were increasing by 1.8%. I'm not here to scare anybody. I'm sure that it's possible, and I will explain it later on. Let's zoom in a little bit on Semiconductor. No. Yeah. So again, I'm not a semiconductor expert or a wafer expert. And when we talk to most of you, I guess, and when we talk to the different players around the planet, we see that most of the players take some very ambitious targets. You have committed to the markets, to the stock exchange, to your shareholders, a lot of efforts towards sustainability. There is one challenge that we have here over the previous talks is your growth. You are expanding, you are investing billions and billions of dollars to increase your capacity to grow, which is tremendous. At the same time, you have to reduce your carbon footprint. Is it possible? Is that achievable? I will give an example that I know very well. My own, yeah, that works. My own company. ENGIE is an energy company. We are a very, very large energy company, a very carbon intensive business. We are producing electricity, we are selling gas, we are transporting gas, we are producing utilities, we are providing electric vehicles, charging station, we are doing all those kind of business. That's carbon intensive, as a matter of fact. On top of that, I cannot say that we have the same growth than most of you, but we still have a decent growth. We have still managed to make some very good achievement towards sustainability and to make a commitment to be net zero by 2040. The question is how? Just to give you how energy intensive we are, because that allow me to say that I'm not here to say to be hypocrite saying please do something, we are not doing it. So we are a very large energy power producer. If I take Singapore as an example, we own Senoko, we co-own Senoko, sorry, which is the biggest power plant of Singapore, located in Woodland. We are the biggest owner of urban cooling systems. So for example, in Punggol, we have a district cooling system deploying chill waters to the entire district. We have a lot of other business. We are a very big footprint around the world in many different countries, which is obviously very carbon intensive. If we look at what has been done, and I only start from 2019, we have started to reduce our carbon footprint by using a lot of different expertise, different technology and so on. We are roughly reducing by 10% per year right now our carbon footprint towards two different progressive steps, which is first 2030 and then 2045 and net zero carbon. If I start with 2019, it's not because I'm hiding something bad behind. It was just because it was worse before. Before we were very exposed to the coil business, and we have decided in 2015, when we embarked in our transition, we have decided to divest or to close all our coil-related business. But I'm not here to say that's the best way to reduce your carbon footprint into divest business. That's not the point. So this is why I start from 2019. How to do it? Plan, reduce, and decarbonize. We shouldn't look at the low-hanging fruits. Okay. Part of our business, we are deploying solar on the rooftops and financing solar rooftops. So I'm not saying that it's a wrong idea. It's a very good idea that everybody should do. And I'll come back to that later. However, this, for example, will not drive the decarbonization, and that will never allow us to collectively achieve what has been committed in the different COP recently. We need to have a holistic approach. We need to have a proper decarbonization roadmap at different level, large corporate, site, specific fab, specific services. We need to look at the global picture and then reduce. We hear on a day-to-day basis, especially in Singapore, where it's a very, very hot topic, is do you have access to green energy? Before trying to have access to green energy, let's reduce the energy that we consume. There is thousands of solutions. Every single site that we have looked at has opportunities of energy efficiency on the utility, on the process, on many different aspects. From there will always be a remaining, and that remaining need to decarbonize. Is it your responsibility? Is it my responsibility? Partially. Is it the government's responsibility as well? If we want green energy, we know that in Singapore, we need to think about H2. We need to think about green electricity coming most likely from overseas. This is something that the government is planning. So it's not our own responsibility. It's a collective responsibility between different parties. The transition journey is a cycle. As I mentioned, we need to have a proper strategy. We need to have a proper roadmap, and we are drafting that for many of our clients. From there, we need to execute our plan. We need to look at energy efficiency, deployment of whatever system. From there, we need to monitor. Digitalization, Industry 4.0 is key, trying to get as close as possible the data from each system, which may be energy consumers. From there, we need to re-update the original plan. We need to update the roadmap and do it again and again and again. And that's the only way to do it. The reason being, this cycle will be impacted by things which are not under our control. The legislation, I was mentioning earlier, the green electrons. If EMA opened the tenders to further import from Malaysia, Indonesia, or wherever, green electrons, that will help us to get access to it. If H2 become a viable solution in Singapore, that will help us to reduce our electricity and our energy. But technology can be a game changer as well. Electric heat pump come in, boilers as well, chillers get better and better. So again, that cycle of roadmap actions, monitoring, roadmap actions, monitoring is a real life and a real permanent question. To conclude, I will try to go to the next slide. Yes. To conclude, I would like to give you an example. This is not the biggest footprint that we have managed to reduce. It's not the largest project that we had to handle, but it's a very interesting project for the simple reason that we have started that journey less than a year ago. 1 year ago, we met a client which is working in the pharmaceutical space. We had 3 sites around the region. Some were greenfield, new construction, new expansion. Some were brownfield, very old site with a lot of things to do. The process were different, each of them. There was clean room, there was production of chemical systems, there was a lot of different things. We made that holistic plan with the decarbonization roadmap together with our clients. We look at everything, utilities, production of different tier water, compressed air, steam, glycol, refrigeration, management of clean room, everything. We look at the process itself. What would be the impact on the energy consumption if we change that aspect of the process? We have worked hand in hand with him to look at all this. We expect that when the different work that we are doing on the 3 factories will be done, including the deployment, of course, of solar in some of them, we will have reduced by 30% the carbon footprint of the clients, only by optimizing and deploying some simple solution. None of those actions cost him any premium for that company. There is no additional money. Green energy is cheaper than the grid. In Malaysia, we believe that solar, when we are deploying solar on the site, the cost of electricity produced by the solar panels are 30% cheaper than the grid. And we still see some roof without solar, which I don't really understand yet. So all this comes with absolutely no cost for the client, only a commitment and a partnership. It comes with more reliability, which is, I know, very important for the semiconductor businesses. And is managing thousands and thousands of central utility plants around the world. We have the balance sheets to take the ability to take some commitment about the performance, about the availability of the different utilities. And last, it did not take any investment. He's investing not as much as most of you, but indeed he's investing a lot of money in new factories. He doesn't want to invest in side business to invest in terms of money, but as well in terms of time. So we leave that to a specialized company, which is NG. And that helped him to reach that target. It's not the end of the journey. As I say, now we are monitoring and starting again, which will be then trying to supply of green electrons. I think that I'm a pretty optimistic person, so I'm not trying to scare anybody here. And I'm sure that you have heard that kind of information, that kind of data many, many times already. I was trying to explain over a pitch, we are more related to energy, what is our responsibility and what can be done. If we act now, if we act actually yesterday, this can be a beautiful opportunity. It can be an opportunity to reduce your OPEX. It can be an opportunity, to stabilize your OPEX, not being impacted by the USEP and electricity price, by the natural gas price, which is unpredictable, unfortunately, nowadays. It can be an opportunity to change and improve various business model and the operation that you have with different way to work and so on. And last, it can be an opportunity to have a kind of meaningful impact, which we all hope that will allow the different stakeholders, governments, persons, corporation, to reach whatever has been committed over the last COP. I will be here this afternoon and I will be very happy to have you feedback about how you take sustainability, how we hear most of the discussion that your product, Semicons, help the decarbonization and help energy efficiency. I'm very happy to have some discussion like this with any of you to try to understand your concerns, and to try to see at the end how we could support all of us. Thank you very much.
Thank you so much, Guillaume. Now let's welcome our next speaker, Mr. Joseph Chia, Vice President and General Manager, GigaPlus Fab Global Foundry Singapore Private Limited, to talk about the topic of talent, the crown jewel of the local semiconductor ecosystem. Joseph, please.
A very good morning, everyone. In this room, I could see across there are many colleagues as well as friends of the local semiconductor ecosystem. So I'm very happy to see you, and I'm very pleased to be invited by SSIA to touch on this topic about talent. And earlier on, you heard from Mr. Bo Huang. He has actually said that talent is a very critical part of our whole ecosystem, and it is a neglected one, very much neglected, that's not being spoken about much. So today, I'm going to title my talk as Talent, the Crown Jewel of the Local Semiconductor System, Ecosystem. Crown Jewel, all right? Of course, I'll unpack it a little bit more to what I call a mnemonic, a kind of memory device using 4 C's, all right? Not the 5 C's that typically Singaporeans are familiar with. All right, so let's go. The first C, all right? The first C, sorry, I realize I'm controlling this. Okay, the first C is that it's a context, all right? Okay, let me start off by introducing a little bit about Global Foundries, since not all in this room is from wafer fabrication, all right? What we do in that Global Foundries is that, of course, we make semiconductor wafers. We're one of the world-leading semiconductor manufacturers, of which we have 8 fabs globally. And what we do is that, of course, we produce the wafer where our customers take it to die, chip, bond it, put it on board or modules, and of course, serve all these end markets here. And you could see all these are the cutting edge end markets today. Now, Global Foundries essentially have 8 fabs, of which I'm responsible for 3 of them here in Singapore, which as cluster, we call it GigaPlus, 200mm fabs. And of course, we have a fab that's running 300mm here as well. And then we have our sister fabs in Germany and US. What we do here is, of course, we're changing the industry that's changing the world. We believe that we will change the way we live as a whole humanity. All right. Now, you could see that we talk about growth a lot in this morning. And these are all the mega trends that's reshaping the global economy. You could see, of course, the Internet of Things. Just the Internet of Things alone, actually, just in 1 year, it grew approximately from 2021 to 22, about 20%, all right? You talk about 5G. This is a hot topic today as well. We know it enables a lot of things because it's a high speed, high bandwidth. In fact, autonomous driving cannot happen without 5G. And this is where it's also growing leaps and bounds. In fact, it's growing about approximately 50% a year. Cloud computing, we talk about this, advanced networking, enhanced security. This is also growing in the ballpark of 45%. Similarly, with artificial intelligence, edge computing, machine learning, advanced analytics is also growing at 45%. And then, of course, we talk about next generation automotive. One of the speakers touched on that. It's also growing very fast at 20% anytime in a year, all right? And I'm very much involved in this because I myself is very interested in this automotive industry all along as a quality practitioner in the past, all right? So with that, we are driving a new generation of low power, highly connect semiconductors. Now, this is what we call a new golden age for semiconductors. It took us 50 years to come to where we are today, where it's standing at 500 million. But it took us less than 1 decade, actually, to reach 1 trillion. In the past, it's driven mainly by PC, as you could see in the start of this trend. And then, of course, later on to data center, networking, mobility, and now of late, everywhere. Everything is pervasive, as you could see right now. And you see, this is going to be done within less than 1 decade. If you survey all the industries out there, there are about 10 industries that could cross 1 trillion in less than 1 decade. And we are one of them. All right. So we are in a very exciting phase of our journey here thus far. Of course, foundries, where we are playing in, like global foundries, are very essential to global GDP. You could see that the whole global GDP stands at 89 trillion, of which if you distill down and funnel down all the way to the foundry, you'll see that it's 93 billion, of which we are talking about only 5 at scale who's playing in that, and it's growing at a CAGR of 9.8%. Very phenomenal, very staggering, all right? And then with that, coming more to a home base here in Singapore, you'll see that we are the largest manufacturing contributor to Singapore's GDP. All right, just now, if you heard Mr. Alvin Tan, he talks about it. I'm quoting 2019 GDP numbers because you realize that 2020, 2021, we are in the COVID years. There is a little bit of dampening in some of these sectors, particularly in transport and retail. So I take this as a good reference, and you can see our manufacturing pie, a slice of the pie, 19%, 6% dominates by electronics, and this is still growing. All right, and even among manufacturing, electronics is the biggest slice of it all. So with that, I want to talk about the seismic shifts in foundry space that we are in. Okay, this is where you see that in the past, people chase more as in M-O-O-R-E. But today, we are in a new era of more, where we're actually dealing with more feature-rich technologies. In the past, supply leads the way, all right? But today, supply actually chased demand, okay? In the past, we built fabs, we say, hey, we built it and they will come. But today, we don't want to do that. We have partners to build the fabs together, where there's skin in the game. And then, of course, in the past, there's also imbalanced value capture. Time to market is the only differentiator. But today, we are doing very much into security and differentiation. That's where our value is. So with all these structural changes that you're seeing in the foundry space, this drives a very unique and very, very interesting opportunity for GF as a whole. This is where I talked about the skin in the game just now. We are building our 7H, and you could see that we actually broke ground last year, June. And now, coming to this next month, June, exactly a year, we're actually going to move our first tool in. Phenomenal progress. And we're on track despite the COVID challenges, despite the constraints of supplies that we talk about. We're still pushing on, and we're on track. And production would start, and we will start shipping in first quarter of 2023. With that, of course, you realize that I borrowed this slide from SSIA, where it talks about the whole ecosystem here. And it's, of course, highly complex, interdependent, of course, fast growing. In fact, we should plot more into this map now because there's a lot of SMEs who are actually collaborating with us in this space. So this map will be more crowded, more colorful, all right? Okay, the next C I'm going to touch on is challenges. Now you see the whole context of where we are. I kind of color it a little bit more. We always talk about explosive growth, but I kind of give you a little bit more color to it. And this is where the real challenge is today. I title my talk as Talent, the Crown Jewel, because I truly believe, that talent is the most critical asset that we have. In fact, a lot of time people like to picture their people as well as their talents as the foundational stone. I understand that, but I kind of want to rephrase it and reframe it for you so that you see that it's actually the crown. It's actually the premium, the prestige that goes with it. And I kind of borrowed a very colorful crown here, the crown of Mary of Modena. If you read it up, you Google it, it's actually a very interesting crown. Very, very precious. It has many, many diamonds and diadems on it, okay? So I'm using crown jewel metaphorically. It's the most valuable, attractive thing in a collection or group. And as such, It applies to all of us in this whole ecosystem. Now, of course, you must have heard of this by now, the Great Resignation Wave. And of course, it's not just worldwide, it's actually hitting, of course, even Singapore here. Now, this, of course, is coined by a professor called Anthony Klotz of the Texas A&M University. He kind of predict this great exodus that's to come of people leaving their own companies and industries. And it's true. Here we are. We have the Great Resignation in Singapore. There's a pickup by a CNA. We have, of course, a SIMI that talk about the Great Resignation in the microelectronics industry. We talk about, even CNBC is saying that 44% of workers are looking for a new job. And of course, there is also one survey that's done, and that actually colors even more for us about the SMEs, partners that we are collaborating with in this particular space of our local semiconductor ecosystem. You see that the numbers are very staggering, all right? You could see that are more employees resigning now compared to 12 months ago. Strongly agree, and agree takes up more than 60%, okay? All right, with that, of course, there's a talent crunch, okay? Demand increase. Just now we talked, we are all expanding, we are all growing. Now it's projected that 20% more increase of talents is needed, actually in the technical skills and capabilities. Okay, now with that, we know there's also a constrained supply. In the COVID years, we know that, we are kind of a lockdown of sort, our borders are restricted, so our talents are very limited coming from neighboring countries. The other thing, of course, is that the local engineering cohort, if you know, in our local universities have actually shrunk. Some of the sub-disciplines say they used to have 200 students, but now it's doing good to something like 50. So we are after a very small pool of talent, so to speak. And of course, the recent local survey of general survey of not just semiconductor also pick up that 45% of our workforce is looking for a new job this year, and 85% don't really feel engaged in the workplace, which backs to the point that just now Mr. Bo Huang was saying that organizational health is another very important aspect of dealing with talents. Now, what does this all mean for us is that, of course, there's a talent war. Talent war that is real, that's intense. And it's a kind of a play of musical chair. So A hired from B, B hired from C, and then C hired from A. We are into this musical chair thing, which is not really a very healthy trend in my view. And last but not least, I would just want to say that we could only win together if we are committed to actually build the talent pipeline. And that requires all of us in this room. Now, this is something familiar to all the HR practitioners. By and large, people will have this framework whereby it talks about how they do talent acquisition to training, development, performance management, total rewards, and succession retention. At the center of it all, of course, is a strategy that links to your business and the needs of your people. And of course, today we also talk very much in DEI, where it plays very strongly into how we can actually have a very inclusive environment. All these are levers for us to actually work on to, of course, attract, develop, and train our talents. Okay. All right. So with that, GF actually has obtained certain recent rewards, of which we are very thankful for. We're also very glad. One of which we've been working on is actually a great place to work. And this affirms again our culture, our organization culture, the health of our organization. This is from March this year. All right, so as you know, it's certified year-on-year basis, so we got it, and it affirms our culture. The other thing that we just got is from GEO, which is a Global Equity Organization Awards. We got this most innovative plan design with regards to equities, how we pay our people. All right, and then last but not least, the New York Business Council actually gave us just this month a leadership award, of which it recognizes us in how we develop our leaders, business leaders, how we actually groom them, at the same time to recognize the contribution that they made, that innovatively made in this marketplace. So with that, I will come to the third C. Okay, I start with context, challenges. Now I come to the third C, collaboration. We definitely need to forge deeper collaboration across all this. We talk about institutes of learning, not just the institutes of higher learning, but across all institutes, we need to do that. We need to influence the students, particularly who are making their choices. So I was having a conversation just now with Mr. Ang, our executive chairman of SSIA, that actually we should continue to penetrate the schools, the secondary schools to junior colleges, before they even make a decision of what path they want to go. I've been part of it. I've been reaching out to some JCs. I also heard that Mr. Ang has actually reached out to secondary schools. So I think there's a lot of partnership that we can do in this space to help influence and stir the ship to the right direction, all right, of our upcoming talents. Then, of course, we work with government agencies like EDB, even the Ministry of Home Affairs, MINDEF. We actually do career talks, Workforce Singapore, E2I, definitely. Industrial associations like SSIA, SIMI, UI, all these are partners of ours. And then, of course, last but not least, the whole ecosystem partners, where we have material suppliers, equipment vendors, IC designers, and of course, the local SMEs. All right. I'll give a little bit of a color of each of how we collaborate with each of these pillars here. So the first one I'm going to touch on is with ITE. We're building technician talent pipeline. I signed a memorandum of understanding on behalf of GF on the 8th of November last year, and it covers 2 areas, internship as well as a work study diploma. I'd like to touch on more about the second point, the work study diploma, in case you do not know. Actually, the moment we recruit these so-called students who are studying for the diploma, after they graduate from ITE, they sign on as employees of GF. All right. And this signing on with GF is actually for 2.5 years, of which for Singaporeans and PRs, they are also granted an EDB grant. All right. And in 2.5 years, once they graduate, they will become associate engineer of ours. So in that way, it's a very good training ground for them, grooming them. But at the same time, it also helps us because it's also a way of retaining the talent that we have groomed. So this is definitely a very good program that I'll also say that, thanks to EDB, thanks to ITE, that we can collaborate on. We also collaborate a lot with polytechnics. You could see that we collaborate with many polytechnics, but of late, we did something very interesting. We actually called the industry holiday program. You know, a lot of students, if you tell them about semiconductor, they'll say, huh? Okay, they have no clue. In fact, they use a lot of gadgets that we produce, I mean, so to speak, but if you tell them wafer, you tell them chips, no idea. So we actually reach out to them. As we see the dwindling of internship and all that in the past, we say, hey, we should do this. We should actually invite them and during the holidays and work with them to spark their interest, to educate them, to help them understand what we are doing. And so we piloted this with Republic Polytechnic. And interestingly, after the program, 85% or more indicated that they want to be our interns this coming year when they do their final year in the poly. So this is something very exciting for us. You could see there are some fun pictures here. We even teach them how to build transistors using Lego blocks, as you could see. You know, we talk about transistors and people had no clue, so we have to use Lego blocks to kind of construct it. And then you see that, of course, we give them plant tours and things like that as well. But this is a very important way to engage them because we need to speak their lingo. We need to be able to reach out to them and get them interested. And we're very happy that more polytechnics are actually joining us on this track. And then, of course, we collaborate a lot with all the local universities here, but not just local. Actually, we also collaborated with the regional ones. But on the local side of things, there's also work study degree programs. This is very good as well, when they come as interns, but they're also studying for a degree, but at the same time, they're working with us, especially engaged on GF projects. And then, of course, we do exclusive campus and fact tours to help them understand all the opportunities that is out there for them the moment they graduate. All right. I've mentioned there's also a GEM program there. This is one of our specialized GF program whereby we attract students that is greater than GPA of 4.0. Actually, we give them a accelerated track of training, and then we actually nurture them to become our next in line leaders. All right. We collaborate a lot, of course, with government agencies and industrial associations, as you could see here. I shall not read it for you. But maybe it's worth mentioning that one of which is upcoming is the one under IC Design Summer Camp. Of course, it's called Summer Camp here. It's happening on the 20th to 22nd of July. And again, it's in collaboration with SSIA, a lot of eco-partners in this system. Interestingly, we are honored, GF is honored to be picked upon as giving them a line tour, explaining what we do in the wafer front. But actually, they are designers in terms of interest. So they will be doing things like hackathon, where they're actually going about IC design competition of sort. So it's another very interesting program that I think can help build the whole ecosystem. And that's what we need here in Singapore. We also work a lot with partners. Of course, our equipment partners, as I talk about, our material partners. But more than that, of late, we have been doing a lot with SMEs. So more than greater than 30 SMEs are deeply engaged with us in terms of technical projects. And this is of interest, of course, in this particular Business Connect. We talk about advanced remanufacturing. The whole idea is talking about how do we do 3D printing for obsolete parts, or how do we remanufacture certain things, as what Mr. George also of Intel mentioned earlier. All right, going directly to the foundries. And then we talk about Industrial 4.0, renewable energy. Just now our speaker just spoke about it. Very important, like our chillers, how to find efficiencies on chillers. We're also on the journey to zero carbon. And with that, we're committed, GF, that by 2030 will be 25% reduction. And we're on track on that. We really want to press on that. And then, of course, there's also interesting part. We co-develop equipment with our SMEs here, things that we need that is not available out there. So, for example, with this advanced spec, which is a tester equipment that we need, actually we co-develop with them. So these are very exciting opportunities that awaits all of us as we grow this industry. And there are special events. I was saying that I'm very interested in automotive space because I'm also a quality practitioner. Zero defects, very, very key, right? So a lot of our suppliers have very little inkling about this. So we actually invite them to Automotive Week, not just to inculcate the idea of zero defects to our own employees, but also inducting them along, helping them to understand our requirements so that they can supply us the materials that truly meet our standards. So that's something that's very exciting that we've been doing and we'll continue to do. All right, with that, let me come to the last C, a call. Okay. Now, this is a call to action for all of us. We say talent. Of course, we say is it hard to find? The question is, right? So let me give you a personal anecdote. The other day, my daughter came home after her work, and after greeting me, she said, "Dad, I've been working under the desk the whole day." So I was very puzzled. You working under the desk? Why are you not working at the desk? Why under the desk? Then she smiled at me and then kind of broke into laughter after hearing it. Is because talents are hard to find. Yeah, even talented people are hard to find. Well, it's just, of course, her chickiness as usual. But it does tell me something, right? It's true. All of us need to spot our talents, even the ones that is with us right now. We need to work on them, helping them to groom, helping them to grow. And then with that, right, we need to deepen our ecosystem partnership. All right, I think we need to have innovative dialogues. Just now, we're talking to Mr. Bo Huang, as usual, about his talk. I was very interested in his talk. He said that maybe we should have a round table of a sort dealing with talents. I'm in full agreement that we should explore that. And then, of course, Mr. Ang, as I said, there's a lot of opportunities that we should work with SSIA in reaching out to all the schools, secondary schools, even if need be, primary schools. All right, I think we shouldn't restrict ourselves in that sense. And then with that, that will, of course, we need to collaborate better, collaborate broader. And of course, we need to also invite ecosystem levers to return, particularly to this super exciting industry that's exploding right now. There are people who left us for other industries because they thought that this at one point was so-called perhaps perceived as a sunset industry, but things are turning around. So I think they should come back and revisit us. And of course, they're welcome to join back. Last but not least, to build a very inclusive, plural environment. I think we need to reach all spectrums of talents, be it, of course, we talk about gender equality here, but also the fact that we need to reach the young ones as well as the more seasoned workers in our midst. I think we need to do that so that we can enhance, and build truly a diversified and inclusive industry. So with that, I'd like to play a little on the lighter side, since I'm standing between you and lunch. So of course, talent, right? We talk about talent. America got talent, Britain got talent. Of course, we can say, semiconductor itself also has talent. And indeed, in GS, actually, we have a lot of talents, not just in engineering, but in other aspects as well, which I'll show you a clip very shortly. When COVID started, everybody, of course, was kind of locked down, right? Everyone had their own homes. So I wrote a song of which I reached out to my international colleagues over the globe, since GlobalFoundries is a global company, and to express solidarity as well as encouragement to one another. We sang a song virtually on phones, captured by phones, and then of course we stitch it together and we publish it. It's the first in the semiconductor that comes together to do that. And it's on you can find it on LinkedIn, Facebook, Twitter's, actually April of 2020, at the start of the pandemic. Last year in our Racial Harmony Day in Singapore, I retook that song and I of course remixed it with the racial harmony concept in mind, whereby we actually invite different ethnic musical instruments come in and of course different nationalities to sing it. Now, I kind of want to share this with you because it's a microcosm of what we can do together in this ecosystem. We come from different backgrounds, different experiences. We talk about people from energy, and there are many others apart from the semiconductor mainstay. I think we should collaborate, and that will actually bring us and help us to propel to the $1 trillion that we talked about earlier, all right? And truly, talent is our crown jewel. With that, let's roll the video. Thank you.
When life becomes uncertain,
the need to stay apart,
to face it all alone. How long will this go on? When fear begins to threaten, it starts with your heart.
arise to fight and build.
Never ever give up.
We'll join our hearts as one and soar together. Hang in there when you feel down. We will look out for each other. We are here for one another. We are never too far. We will be around. We will stand tall and forever. We are one GF together.
Welcome back, ladies and gentlemen. I hope great lunch and also a great opportunity to network and check out the exhibitions outside. Now, for the afternoon session, we will be exploring technology. Quality management for incoming goods. So please show me to welcome Brian.
Hope that everybody have your lunch, and thank you for SSIS to organize this events here. Great to have you all joining me today for these presentations. My name is Brian. I'm actually the VP of Sales and Business Development for Chemline. So a short introduction about Chemline here. So we are a 30 years old company founded in 1989, and we have business around the world in Singapore. So we started in year 2002. And there are really, we have part of Finland's group now, telco companies, and we are providing software solutions for your manufacturing and process controls in automations. So if you take a closer look, we have different product solutions available from ChemLine. Especially, we are focusing today the topics of quality assurance. And we also have solutions that manage your productions and operations and automations here. So for my topics today, actually, we would like to focus on supplier quality management for all incoming materials. So as previous speakers that we have, we all know that supply chain is a big problem for semiconductors. But besides getting the supplies, getting your supplier qualified, you also want to ensure that the material that you receive has the quality standards that you want, and also able to boost or work collaboratively with your suppliers to improve your incoming materials. Yeah. So let's have a go deeper here. And for manufacturing, we always talk about having digital continuity instead of having silos data that you capture. So you want to make sure that all your data are connected, having all the continuities that you can support your operations. Your data is actually the powers to enable improvements for your operations here. So to have a guaranteed supply chain does means that you need to have better combinations of suppliers that from different locations to supply your plants. If you look at today's landscape, you have more than just one supplier that you need to manage. They actually has multiple suppliers that come from different sites, locations for materials that you purchase. Knowing who is your approved suppliers, that really helps you to give you transparency to manage your operations better. And the materials that you bring in, the next thing that you would have is how good is the quality of the materials? Is it really compliance to your requirements? And in the markets, we always talk about electronic C of A, the certificates of analysis that you analyze on your goods that you ship to your doorsteps. So which supplier from which location, shipping to which fabs around the world, is it qualified for your operations needs? And then we would like to definitely introduce a system that is called supplier quality management that does all these online validations, ensuring the data and the quality meeting your requirements before they reach your doorsteps. And that's where an online system like supplier quality management really provides you a transparency to look ahead before the actual shipments arrive at your doorsteps. So you do not want to, again, ship back or reject the goods when you arrive at your doorsteps. You want to make sure that you are having a quality assured, good product delivered to your doorsteps here. So while in the delivery, in the transports, there's also data collection. Some materials are sensitive to the transports. You also want to collect those data as well. So again, the systems such as SQM does help us to track all those data. And when the materials is qualified and arrive at your doorsteps, do you know that if it's ready to be used in production, or you would like to do more inspections? So this is another judgment steps that you want to ensure the right material gets to your production. Not just arriving at your doorstep is enough. Yeah. So having the inspections on site, incoming quality check, maybe you would even implement a skip plan that you don't have to inspect 100%, or you build up your trust with your supplier that you totally skip the IQC in long run, right? So your supplier, what they have spent investments to measure, they already spent a lot of efforts to bring those data inside their production, they can share with you, actually. And if you have built up the trust, straight away you can issue it to your productions and get ready for your productions to use. And that's the digital continuity. This is the first beginning part where the materials that you source it's getting the right quality to your doorsteps. Okay? And you have all this data in your hand so that you can continue to use it for your productions, to drive your operations to another excellent level. Yeah? So that's where LineWorks SQM here is one of the starting points to enable connectivities from your suppliers to each of your location fabs around the world. So the more complex of your metrics, Like you have 700 suppliers versus you have 10 factories around the world. There's a lot of approved supplier list metrics that you are managing. You do not know which fab is buying which product from which qualified supplier site, right? If you look further down, to take control of the data that you have, you also need to enrich it. So take a very good example. If you have an ingot, so you buy the wafer that cuts from an ingot. So when you have the wafer in your hand, you also want to know where are those wafers coming from. And instead of just a summarized data, you also want to have more information about the wafer that you are buying, so that you can use those data to even help your productions to achieve better yield. So having such a context information nowadays is critical. If you do not have, you always have production issue, then you trace back into your incoming, but you do not know what other impacted materials that you might have. Contextually, you want to get all these information into your hand so that you have abilities to do a traceability or a quality control better. So having a platform or systems that supports all this contextual information is critical, not just wafer, gases, spare parts, O-rings that you're buying. You can consider all this material that you are getting into your factory are enriched with all this context information. So these are valuable information that you can use it to help your operations. So not necessarily every time you need to get it to your supplier, give them a AD, ask them to find out why, but you also can have this data in your plant, ready in your hands to always do further improvements or troubleshootings here. So a system that you can support more than multiple commodities became a good platform here. Now, material specs, you always have technology developments and new materials coming into the market. And this is another challenge here. So which suppliers should compliance for a newer specs? So you always would have problems to convey the message or even implement a new improved specs here for your productions. Yeah, you qualify a new materials and you continues to improve your manufacturing. You always have a new spec that you want to implement throughout your supply chain. And that's also come with another problems. Not all suppliers are equal. Some of the suppliers could agree with you that today I would able to take the new spec and make the implementation maybe next month, or some of them even delay until next year. So every supply chain has their own challenge to comply with new technology that you are bringing into the market. So you need to have a platform also to work together with your supply chain, defining who can comply to which spec versions as your plant getting more technology advanced. Yeah. The next part of it is looking at the material that you are receiving. So of course, we expect materials that arrive at your doorstep would not be expired materials. But there are times where shipment get delayed. As you know, during COVID, a lot of shipment problems. They were staying on the dock for a while, and you may have expired materials that you're receiving. So the system as such should have the ability to check all the shelf life before they ship it to ensure there's a minimum expected shelf life. And when it's receiving at your doorsteps, or you submit the ECOA for older shipments, you also ensure that there is a sufficient shelf life for receiving, yeah? And you do not want to receive a material that left only with 2 weeks and to bring it back to your warehouse. So this is something that we also want to prevent materials that have high risk that may cause an impact to your productions. So when you receive a materials, you also want to ensure that material has sufficient shelf life to store in the warehouse, to survive during the transport times and so on. Having an online system really gives a transparency to your operations as well as to your suppliers here. Yeah. Now, if quality is important, just depending on supplier may not be good enough, because there are new materials that you may been introduced to your manufacturing, and you would expect you implement something that is sampling control. So expecting the supplier, if I order 100 boxes, you should at least analyze or inspect 10 of them, 10% of your acceptance check sampling here. And the other thing is your incoming inspections. When you have a new material that you introduce in your fabs, you also want to make sure that you have an inspection plan in place to ensure that they are well taken care of new material introductions, have the right inspection plan in place. And if the materials are mature, you can really implement a skip plan. So not necessarily that you always need to inspect anymore. You can directly issue it to your productions. And this also comes to a point where you build up your supplier trust. If your supplier has a better measurement capabilities, the data quality is good, and you are able to build the trust with them, so you can already implement such a skip plan, allowing the material directly from warehouse flows into your operations. And that does cut down the waiting times of getting the right data and making sure to make the right judgment so that the material gets into your plant. Yeah? Skip plan is always an important part when you come into receiving the materials. Now, behind the entire systems is actually powered by a very industrial, commonly known line workspace SPC systems. So a lot of times in the production line, we also use our space systems for production control, and SQM for incoming materials uses the same platform that provides the engineers having the familiarities of using the same SPC. So not just measurements data, but also quantitative like defects, visual inspections, all this could be just implemented with the same SPC systems here. Nowadays, ship to control is pretty common. It's getting lesser to ship to spec. You probably have a common spec understanding, but as technology more advanced, they are now putting control limits in place, trending rules in place to ensure that you are able to ship to control limits, not just a specification that you specify in your purchase material. And more customers nowadays that we see around the world, they are implementing even more early detections, trending rules to your incoming materials. Why this is important? Because the earliest that you can prepare for your production for, let's say, a bad quality product that is coming in, but it's still within spec, then your operation will be able to mitigate what the changes might be needed, or maybe prepare those materials for other type of production usage rather than for those critical ones. And we do also have, and we do also have another things that we implement in the system is historical high and low detections. So when you have shipments that comes every day, you can't track it in mind, is this the new high point or new low points in your data that you're receiving from your supplier? Whether this shipments has ever been in the past a very low in yield or very low in measured results. So historical high lows is really preparing your operation, no surprises, that you are now seeing some product that is not expecting the operation needs. Yeah. For example, if you have a particle count and suddenly there's a high particle count that you never see before, and this historical high low is a great way to detect and also prepare your operations what they're going to expect if they use such a batch. And there's a lot of good cases now where shipments are not consistent. So they might be, today is a new high point that is detected by the system, comparing 6 months ago, all the shipments that you have. And if you look at it, what is next after SQM? So it's also kind of common that implementing all these digital continuities, data collection from your suppliers, what you could do more for your operations. If you look at equipment, you're using all the raw materials, consumables, spare parts, and you have all the data from your suppliers with regards to those materials that you're going to attach to the equipment. This is another point, what is next used by the productions on the process equipment. And also at your facilities. And this is where all the gases, slurries, that has been pumped into your process equipment from your facility end. This is where the materials are connected. Do you have the traceability to know all the materials that you buy from the supplier are now connected to which facility equipment that pumping it to your process? And this is another traceability issues that we also see in the markets, and we try to introduce other important software components that can deliver such a traceability to the customers. So looking at this, if you look, does it work? Or collaborations, if you have materials that is not compliant, and you will do an improvement plan, online collaborations with your suppliers, and exchange what is their actions plans to improve the next quarters or the next shipments that you're going to receive. So having a collaboration platforms, improvement plans management together with your suppliers really increase what we do today digitally. And then followed by another levels here is that with your facility that you hook up the equipment, you give you a transparencies to know when the materials really being used, in which sequence, and are they affecting some of your process? Having the ability to track each of those batch materials that is connected to your distribution equipment, this become a normal that you want to help your operation to find out if the materials that you use now is having impact to which process tool, right? Materials that you buy from suppliers for your equipment, there's another traceability in the maintenance. So all the data that you collected from your supplier can be connected to your maintenance systems to trace that this spare part that you buy from, is it better than the previous batch, or these batches of consumables that you have, or CMP pads that you want to put on the tool, is it having a much worse quality compared to the previous shipments? And this also become a very key part of the information for maintaining the equipment, having the right equipment with the right materials, with the right qualities that you have in the operations. And with this coming to the end here, in productions, you always would have process control in place. When there's an excursions happens in your process tool, you also want to find back the incoming material quality data. And you want to find a way back to link those informations that you can help your operations to diagnose what really happens to your process tools. So with the inline SPC systems together with the incoming quality check controls, you will have a complete capabilities to connect all the data that you collect from your suppliers, correlated to your operations, and enabling in the futures for a better digital continuities and process monitoring here. So that's what I have today for you all. And great to have you all here today after the seminars. Maybe we can explore more at our booth in front. Thank you.
Thank you so much, Brian. Now let's invite Mr. Mike Feng, Chief Technology Officer, InnoWave Tech Private Limited, to talk about the power of artificial intelligence achieving industry transformation goals. Please join me to welcome Mike.
All right, Good afternoon, ladies and gentlemen. Thank you for being here, and thank you SSIA for organizing this event. My name is Mike Feng, and I'm the Head of Solutions and CTO of InnoWave Tech. So I'm going to try to be as informative as I can on how AI can transform manufacturing. So a very quick introduction to InnoWave Tech. We are an AI company that offers solutions to the semiconductor and advanced manufacturing industries to assist companies in achieving their industrial transformation goals through the power of AI, specifically machine learning, machine vision, and computer vision. We serve some of the largest semiconductor companies in Singapore. And in our time, we have observed certain consistencies in the application of AI in these companies. Some of the previous speakers have already mentioned, and also in the morning as well, due to the challenges and overwhelming need to increase output and quality, manufacturers are pouring their efforts into AI. And the adoption of AI in semiconductor manufacturing is no longer an extravagance limited to a small team of automation experts. Instead, it is very vital for the company's growth with strategic and long-lasting outcomes. Is it working? Okay. So what are these outcomes that we seek? A phrase very commonly found or used in China to describe these outcomes is 落地 AI, which loosely translates to landed AI or applied AI. So in our experience, the best way to look at how we can achieve these outcomes is from the point of view of how AI is applied or can be applied. Here are some of the more common applications that most of us have heard about. For example, in wafer manufacturing, defect detection and recognition using computer vision is a very much sought after solution, especially to replace manual front-end inspection, typically by operators looking through microscopes. Another very common application is in the use of industrial IoT, from monitoring remote assets, for example, by planting a camera in front of your sensors, your gauges, and HMIs, to collecting multi-dimensional data from equipment for predictive and prescriptive maintenance. Now, I want to take a minute here just to emphasize that for IoT sensors, they merely collect data. Most people tend to think that the challenge is to then create a model accurate enough to analyze this data. But actually determining the right data to collect in the first place is more difficult and oftentimes require very specific domain experience and expertise. Speaking of collecting data, WIP traceability is almost always the first step to automate a factory. You first need to know where all your stuff is before you can do what you want with them. As such, smart storage systems or sensorized e-racks that collects and integrate these data with existing systems like a MES, your ERP, or your dispatch system are essential to any intelligent manufacturing. So now let me take a minute to dive deeper into defect detection and recognition. Many semiconductor manufacturers today often have rows of operators, right, looking through microscopes to detect and identify macro and micro die level defects. By using optical sensors in combination with various illumination methods, advanced computer vision models can differentiate and segment standard patterns, non-standard patterns, noise, and finally the defects themselves, just using AI. Right? By inserting this inspection in between certain processes, we can then create an additional layer of analysis that can trace the defect's root causes in problems often associated with equipment and process. With the help of AI, the entire process can be now automated today. From image taking, lighting control, image processing, defects recognition, all the way to root cause analysis and predictive maintenance. Companies can not only reduce manpower, but also obtain valuable information to help them transform how process and equipment can be improved throughout the production process and production line. So apart from the more generic industrial AI applications we described earlier, we have some products that are more specific to address certain specific gaps in the semiconductor industry. The first one, which I will go into more detail in the next slide, basically automates the operation of equipment by using AI to replicate human behavior. When applied across various equipment types, it can also be a quick, unintrusive way to completely automate your factory. Secondly, in a large factory, there is often the need to deploy engineers or technicians to patrol large areas to identify hazards or take recordings of certain readings. To not only automate this, but also turn it into a continuous 24/7 process, we can mount, say, a sensor array on top of an AMR, program the AMR to conduct various automated patrolling activities, and then use the sensor array to identify and recognize anything that is needed. For example, using a combination of optic sensor, we can accurately detect water leaks, chemical leaks, equipment temperature or drifts in this temperature, sensor readings, pretty much anything that can be seen by the human eye. Another niche product that is really gaining popularity from our experience is using cameras to monitor the status of your different assets. For example, the water or power meters that may be scattered across the factory, or equipment data that traditionally your engineers have to perhaps manually and periodically take readings. So all this can be done by simply set up a camera system that converts images to digital data using AI and then transmit these values, say a value of the water meter, transmit it wirelessly to a central server. Now, if the location is, say, outdoors, you can even power it using solar, because you can try to transmit data over low-powered LoRaWAN communications, so there's no need for even Wi-Fi. Now, as mentioned earlier, one of the, shall I say, more consequential, I think, solutions is AI-enabled equipment automation process, or AI EAP. To put it simply, AI EAP replicates human behavior, right? It replicates human behavior to operate any tool by having software look at equipment, judge what needs to be done, and then autonomously and instantaneously respond with the action needed. All this is completely unintrusive. There's no software or modification required on the tool. AI EAP can process the kinds of judgments that are recipe specific. So let's say there is a scenario whereby there is a tool with thousands of recipes, with new recipes added periodically, all of which is supposed to guide the human operator to handle the tool differently. AI EAP is designed to handle this scenario. By fanning out AI EAP to all the tool types, a factory can then potentially fully automate all their equipment, or at least a very significant part of it. And because AI EAP is constantly reading the status of your every tool, it can send equipment data necessary to, say, the MES or the WIP system to achieve other levels of automation, like automated track-in and track-out, or trigger OHD or AGV transport, etc. The reverse is also possible, essentially of having the MES control the tool through the AI controller, like to start and stop the tool process. So AI EAP allows manufacturers to easily reduce and reskill very significant portion of their manpowers to focus on other value-added tasks. So what's next with industrial AI in Singapore, right? The logical answer, of course, is better and more accurate models, right? While that it will always be true, we believe there are certain developments that have also significant impact and influence in industrial intelligence. First is the shift to 5G. Currently, 5G coverage in Singapore is around 2/3 of the island, and we will have nationwide coverage by 2025. This is changing how AI applications are designed and ultimately deployed going forward. Now, I'm not going to bore everyone here with all the statistics on how 5G is better than 4G or Wi-Fi. These numbers you can easily find on Google. What I'd like to do is bring attention to three main areas on how 5G is redefining certain traditional use cases. So first one is industrial IoT. Right now, probably the biggest obstacle to fully implement industrial IoT is connectivity. I'm sure most people know that if you want to transmit data in a stable way with low latency and high frequency, the best way now is through Ethernet, right? This means that your implementation cost is going to be very high. You have to pull cables, you open up network points, and then the whole project becomes very time consuming. Now, you may also think of using Wi-Fi, but with the sheer quantity of sensors today we're talking about, your Wi-Fi network can be easily overwhelmed. Wi-Fi also suffers from significant interference either to or from your equipment. So needless to say, 4G was never designed nor intended for heavy industrial use because of its centralized nature. 5G gateways that can connect to a wide array of sensors, therefore, are going to be increasingly popular to transmit very high frequency data from whatever you are measuring to a centralized server that can be even offsite, which I'll go into the next one, which is edge computing. Now, 5G is transforming edge computing. Traditionally, the reasons for having an edge computing architecture are primarily first to reduce server resource dependency by moving data processing closer to the edge. Second is to reduce data transfer the distance in order to process time-sensitive data. When it comes to AI applications, I'm sure many of us here understand the problems inherent in this particular architecture. First, edge devices, by definition, have to be more complex to handle more advanced processing. This drives up costs, especially when the solution requires a lot of the devices, for example, in AI/OT applications. Secondly, updating the software in multiple complex edge devices is potentially a very time-consuming and tedious process. Imagine every time you have to roll out bug fixes or improvements, even with an automated push method, it will still be subject to connectivity and stability issues. So by combining 5G with mobile edge computing or an MEC server, we have begun to deploy solutions that kind of reverse these trends. It's not that there's no value in edge computing for 5G. Rather, 5G allows much simpler edge devices that can focus on just ultra-high quality data acquisition. So since latency is low and bandwidth is high, much more complex data processing can be done in real time on the server side instead. Now, the last use case that is going through some kind of redefinition is to combine computer vision with mobile applications. Now, when I mean mobile application, I'm not talking about the handphone, mobile kind of applications, but applications that are actually on the move, mobility kind of applications. So take, for example, the autonomous patrolling robot that I mentioned earlier, or AR glasses with AI recognition functionality, or teleoperation. That's a good example. So computer vision solutions like these that require very high quality and stable video streaming from a moving platform would have been difficult even with Wi-Fi, because of coverage, interference, and stability due to zone hopping for Wi-Fi. With 5G, we can stream 4K live videos to a powerful server that does very highly complex recognition work and have the results sent back instantaneously to the platform. This wide implementation of such use cases is pretty much, I think, in our opinion, exclusive to the 5G architecture. So I think now we are talking about how to stay ahead in the AI game. And finally, we have MLOps. This is going to get a little technical, so please bear with me. First, MLOps is essentially a combination of machine learning with DevOps. It is a useful approach for creating and maintaining machine learning and AI solutions. And by adopting an MLOps approach, data scientists and ML engineers can collaborate and increase the pace of model development and production by implementing certain CI/CD practices, continuous integration and continuous deployment, with proper monitoring, proper validation, and governance of your AI ML models. Now, all this sounds very dry, I understand that. You can just think of MLOps as a data pipeline designed to automate the generating and training of AI models, the deployment and evaluation of these models, and then improving the models further based on the results of these evaluations. So MLOps itself is fairly new, and it's mostly used by AI companies such as ourselves to manage, deploy, and improve our own products. But we observe a new trend, specifically as AI applications and products proliferate in factories, it is increasingly difficult for managers to manage them and near impossible to improve, to retrain the AI to keep up with factory changes in factory needs. So a sustainable way of managing your AI products is now needed. That's why we are planning to distribute our own MLOps platform that we use together with our AI products, which will allow, for example, say our defect detection customers to create their own AI so-called recipes to detect new features, or use a result validation process to continuously improve the accuracy of the existing models that they are using. This effectively means that end users, the customers, will be able to generate and retrain their own models, which is efficient. They can retrain and improve existing models to keep up with their own needs, which provides scalability and prevents legacy issues. And they can fully control access to their own data, which reduces risks related to data secrecy and privacy. So I hope that this has been an informative session. If you have any questions, please feel free to look for me and my colleagues at our booth next door. Thank you very much for your time. Thank you for your time. Right.
Thank you so much, Mike. And next up, let's talk about mobile robots and manipulators for material handling operations. So please join me to welcome Mr. Mazen Najib Anwar, Chief Technology Officer, SESTO Robotics Private Limited, up on stage.
Hi, hello everyone. Very good afternoon to everybody and welcome. Thank you to SIA for having us. So today I'm going to talk about mobile robots and manipulators and specifically how they can be used within the semiconductor industry. Right, so let's begin with the problem statement first. As we know, the recent pandemic and everything else leading up to it actually has increased both the cost pressure and the manpower pressure in terms of labor and supply on many industries, and the semiconductor industry being one. So we have to deal with this somehow, and automation is definitely one of the key methods that we can. All right, so what can AMRs do to help us, right? We're all of us in a production environment. We deal primarily with material movements, material transfer, and a lot of these processes do take up time and manpower away from us, where we could maybe redeploy this capital and manpower elsewhere, right? We also enable a lot more data-driven analytics, right? We can integrate these AMRs directly into MES and MCS ecosystems, thereby improving visibility over the entire material movement chain. Right, and finally, we do allow cost savings in terms of maybe not just in terms of labor reduction, but in terms of a more predictable labor supply. Right. So what will these AMRs do typically in a semiconductor environment? So one way they can help, again, is to automate a lot of the pick and place operations. Right, they can help with long haul transportation when we transport material between fabs or between sites. That's a lot of walking and movement that a human doesn't really want to do, right? And we can pick up errors and handle them a lot more efficiently when we have these AMRs in place, right? So the route management, charge management, and all that stuff will be taken care of by the AMR systems typically. So we can try and focus primarily on the higher level use cases. Right? So within the fab, we typically have several transport operations that we need to handle. Material comes in from a receiving area, it needs to be routed to warehousing, storage, temporary areas, or even directly into processing. Within processing, we have multiple movements between various tools, within stockers, work in progress buffers, and finally within the tools and tools themselves. And finally, we have an out processing sequence where they have to maybe move to a different plant for another assembly process or packaging process, and finally they get shipped out to our end customer. So AMRs can help alleviate some of these highly intensive processes. So before we go a bit further, we can just take a step back and understand what AMRs are and what AMRs do. Right. So they are typically a self-propelled platform. In this case, the platform we see over here has two motors on either side, and as the motors moves, the sensors, the LiDARs, the cameras will pick up information from its surroundings. And we use that to do two things. We use a process called SLAM to build a map. So you can see in the graphic over here that the areas in black are the map that the AMR has picked up and stored in its memory. The areas in red are what the AMR is actually seeing now. And we have the information in green coming from its 3D cameras, so it can perceive a lot more objects, especially since we operate in a 3D world. Right. So once we have the basic mobility portion sorted out, we then have to devise and think of payloads and processes we actually want to automate using this base. So here's where things like mobile manipulators come in place. So we have cobots and multiple industrial arms that we can put on top, conveyor belts, shelving units, and really anything we can use to alleviate a lot of this manpower problems. Right. So a little bit about Sensor Robotics. We are a homegrown company based in Singapore. We've been in this space for about 5 years. We've started primarily in the semiconductor industry and serviced quite a few of our clients within this space. So we've done various applications from big long-haul transporters, capable of moving 300 to 500 kg of material, all the way up to this mobile manipulator setup, which is going to be used for transporting FOUPs. Right. So today we're going to present 2 use cases. The first use case that we're going to be looking at is going to be machine tending, and the other one's going to be more of a trolley transport. So in a typical front-end fab, 300 mm fabs at least, we have these FOUPs, and these FOUPs are what we're going to be using to carry wafers from place to place. I'm sure everyone here already knows that. So there are a lot of steps that a wafer has to go through in order to be completed. And these materials are typically handled either by humans or by OHTs. So where AMRs can help is that if we do have a lot of areas where they have high mix, low volumes, or areas where we cannot maybe retrofit an OHT inside, we can install an AMR quite easily without having to change any additional infrastructure. So the robot itself has obviously the mobile base, as well as a 7-degree arm mounted on it. On top of that 7-degree arm, it has an effector, which has been custom designed to be able to grip the OHT flange of a FOUP. The AMR itself can carry 2 FOUPs, and this enables certain operations, for example, swapping at tools, so that we can minimize tool downtime. It's also got a plethora of safety lasers and safety sensors around the vehicle to prevent people from colliding with the robot, as well as to prevent the robot from colliding with people when the arm is in operation. Right. So just some typical salient points about the platform. This particular platform targets front-end wafer processes dealing with 300 mm FOUP transfers. So right now, our biggest deployment on site, we have about 22 of these robots operating in one fab. They run 24 hours a day, as all fabs do. It's a fully ESD controlled environment. Our robots also have to go through typical ESD inspection routines as well. All the movements, charge allocation, and charging cycles are all centrally coordinated by our central fleet server. And in turn, this fleet server is then linked to a MES on the customer's backend to automatically inject move tasks when a tool is finished. Right. So here we have a video of the robot operating in a fab. Here, the tool itself is a little bit special. It has a kind of a hooded design, and this makes it a little bit challenging for typical OHT systems to handle. And so the AMR with ARM does enable automation of pick and place within these slightly different tools. So here we can see the robot coming into pick. It's scanned. The fiducial we place on the load port of the machine. That allows the arm to kind of relocate, relocalize itself to do a precision pickup. We then get a few more data points around the FOUP and go in to do a pick. Right? So throughout the pick sequence, you can see sometimes the arm stops momentarily, and that's to enable the handshake between the AMR and the tool. We use a typical like a emulated E84 standard where we do check that the FOUP is ready to be removed from the tool and it's been placed properly on the tool as well. Right. So this is another video of a similar process. This is placement from the AMR down to a rack. So we use these racks, or these racks are primarily used in the facility. We call them a 3x3 rack, obviously because they're 3 tall and 3 wide. And these racks are a little bit special. They have intelligent racks. They're able to read the FOUP IDs and tell us what FOUP's on the load port, and whether that FOUP is going to be staged to be taken or what FOUP is going to be delivered onto the rack. Very similar, we have a fiducial on the rack, and depending on which position the arm is going to reach in, the arm will reach down to that particular height to do a scan as well as pick up the FOUP. Right, so in terms of safety, these are pretty big arms. They're carrying heavy payloads, and we do have people walking around and running alongside them, handling other materials. So safety is paramount. We do have quite a number of safety sensors, the primary ones being our side safety lasers on either side of the robot. If there is any breach of these lasers, for example, operators coming in or anybody else coming into this protective field, the arm does stop and pause and wait for them to exit the field before it resumes. Similarly, at the end of the end effector, we have a laser, and that laser allows the FOUP to detect anything that might be oncoming. So if there's maybe additional FOUP that might appear, an obstacle or another person standing in front of the robot, we can pick that up as well and stop the arm. Right. So this is some close-ups of the end effector. On the left-hand side, we have the safety laser as well as a vision system. So that allows us to relocalize and capture highly accurate localization landmarks on the either the shelf or the tool. And within the end effector itself, there are several proximity sensors that we use to detect proper pickup and placement of the FOUP, thereby enabling missed picks or anything else. So a typical data flow that happens within a customer site, we have the order dispatch coming in from the customer's MES system. And this, of course, is a very high level move this from here to there. Right? This goes through an API adapter, so we can account for various semi-standard APIs or even some other MES APIs that are a bit more special. And ends up in our fleet server. This generally has a task ID associated with it, a destination and a source, as well as a FOUP ID. And this then gets handed off to the robot to go and actually execute this particular task. When the robot gets to the tool, then executes a handoff request between the tool and our machine. Once that's okay, the robot will transfer the FOUP over to the tool or the rack, and then it will feed back that system up again. So there's a lot of data that gets generated from this process. We can track a lot of the execution times, any errors that occurred along the way, how hard one robot is working, where is a particular FOUP, how many FOUPs have been dispatched to this particular tool. And all that data gets stored in a database. We can then mine that data, we can retrieve it, we can run analytics, and we can then feed this data back into our customers' own industrial engineering arm. Right, so the next use case that I want to touch on is kind of the bulk transfer. So this would be primarily used in the back-end processes where we have tote boxes full of assembled chips that we have to get from tester to tester or from ovens to other parts of the fab. These are really heavy. There are a lot of material that has to be transferred. And there's generally two ways of doing it. We can do a shelf type robot that we see below, where the operators would load tote boxes onto the shelves and the robot would then move from point to point. Or we can do a trolley mechanism where we have everything loaded into a trolley and the robot picks up the trolley and moves it from side to side. Right, so we just have some examples over here. So on the left-hand side, we had a AMR which could carry up to 12 tote boxes. And this was really for long-haul transportation. The robot was moving at about 300 to 400 meters per trip. So in a day, it would easily reach about 30 or 40 kilometers just in terms of travel alone. On the center, we have a kind of a lighter duty robot. This is typically used within fabs, maybe from a stock or a dispatch station to a tool or tester. And finally, on the right, this is a little bit more specialized. This is actually a spare part and equipment dispatcher. So for example, in a process like CMP or any other consumable process, we have to have a steady supply of parts being delivered out from either the storeroom or some other holding location to the tool for replacement. Right. So in terms of trolley movers, we have a variety of trolleys. These are really customizable to whatever the customer wants. We have a shark cage, again, for bulk transfer. We have separated shelves for tote box transfers, and we have a much heavier duty cage, again, for spare parts transfer as well. Right. So short video of how the robot detects and picks up the trolley. We don't use any particular pickup stations or any jigs or fixtures on the floor. Everything is self-contained within the robot and the trolley. So here we have the robot detecting the trolley. It's found the trolley position, and now it's going to dock into the trolley. And then once it's verified that it's beneath the trolley, it's going to execute a pickup, right? And then it's going to carry it off. So again, the key point is here that we don't have to install any additional fixtures or anything else on the floor that has to be fitted onto the either the fab floor or onto concrete floor, which might upset general movement of stuff. So a typical workflow for these material movements would be, again, coming in from either the warehouse management system or an MES, or even just ad hoc task creation. The order gets dispatched to our fleet management system. All right. It then gets assigned to an AMR to go to a particular location and pick up the item. The AMR arrives at the pickup station. We can then implement things like asset tracking if that's required. We can scan barcodes, RFID tags. We can then scan maybe employee badges to know who was loading and unloading material at a particular time. The operator would then load the material, tap the badge, scan the barcode as required. The lot ID for that that material is then associated to the robots, that we can track that this material is actually being moved along the floor. The robot's going to go to the dispatch station, and the reverse process is going to happen. The operator then taps the badge or anything else, opens the bay, and takes out the material, and then disassociates that from the AMR. Right. We also do a couple of custom AMRs as well. So these are a bit of odd shaped or odd sized platforms. So we have on the right-hand side a pellet kind of construction where it's meant to feed into this automated plastic tray transport and conveyor system. On the left-hand side, we also have a big single plate tray, which is going to be used by the robotic arm over there to do machine tending and feed material into the tool. So that's a bit more on the hardware side. I'll talk a bit more on the software side and what we have to enable that to happen. So on the highest level, we have our fleet management system, and that's going to be handling the routes that we're going to be taking through the facility. It's going to be coordinating the robots to make sure that each one's got the right task. There's no traffic jams or deadlocks that happen. It's going to be handling, choosing the best robot for a particular task, as well as handling the charge management for each robot to ensure maximum uptime. Right. So we generally set up the site by using a web-based interface. So from here, we can see the facility of on the top right-hand side. And from there, we can see the pathways that we want the robot to take, where we want it to go, to wait, to dispatch material to. And that's the pathways that the server will then use to plan its path and deconflict the robots. Right. In addition to that, we have dashboards and additional salient information that we can then display in control centers or in other workstations, so operators and supervisors can pick up that information. So the route configuration can be changed. It can be set up quickly. It can be changed. For example, if there's a area of the fab that's under maintenance, so we want to block off the robots from going there, we can section that off. We can allow the robots to avoid obstacles and give it more leeway to go around, skirt around obstacles, or stop dead in its tracks if it needs to. We can change speed, localization settings, audio warnings, as well as audio alerts as well. And finally, we have task management. So once the tasks have been injected inside our system, we're able to monitor their progress throughout the whole life cycle, whether they're being assigned, have been delivered, is there a problem with the task, is there any issues that we have to handle, and we also can track when they've been assigned to when they've been completed and pick up on the overall machine efficiency as well. Task definitions allow us to change what the robot does and do it programmatically. So we don't have to upload new software. We don't have to do any reconfiguration. A lot of these things can be done on the fly and after the robot's been deployed. So if there's any changes in your process, the AMRs are able to cope with them and change according to your business as well. So ad hoc task creation can be done either through as an operator through this terminal here, or we can use MES to inject the task to the API. So here, if we have a singular dispatch that can happen, that needs to go through maybe just one time on an ad hoc basis. We also have schedule. So if you have repetitive tasks that need to come in periodically, for example, if you have an incoming inbound this material that has to be moved from the dock out to the warehouse that comes in at a routine time, that can be scheduled in, and our system will then take care of that. Right. So I think the last point on alarms and the management, user management and events. So as we get into a more secure environment, data management becomes important. Who's going to be doing what to the system has to be logged and maintained, so we know who's been changing what. We also have to respond accordingly to alarms and events. So if anything does happen to the robot, we're able to sense that and perform any corrective action. Right. So I think in conclusion, the maturity of the robots has significantly brought down the cost it takes to deploy and maintain them. We can get pretty good ROIs on our robots quite easily nowadays. I think the market as well as the various forces are right for adoption of these platforms within many production processes, and I think the semiconductor process industry is a good one to start as well. All right, I think if there's any questions, you can come by our booth next door. You can approach me and you can have a chat about the AMRs too. All right, thank you very much.
Thank you very much. Now, ladies and gentlemen, we'll now head into a tea break and we'll resume the rest of our program at 3 p.m. So I'll see you all shortly.
You turn your back on them. That's not what I was told. And maybe you need a new lesson. Repeat after me.
A good break. All right, so we have 3 more presentations before we end the day. So for now, let's welcome Mr. Ho Boon Chai, Chief Executive Officer, August Building Performance, to speak about energy optimization at $0 investment.
Thank you. Thank you so much. Okay, today I'm going to talk about energy efficiency. BBP is essentially a company that's founded to save energy use in cooling. The technology that we use help different buildings and facility save energy. If you look at a commercial building, it uses about 60% of the energy for cooling. And if you look at data centers and industrial building, here we are talking about semiconductor wafer fabs. Hang on. Okay, I'm hearing an echo. That's why. Using a mic, okay, no problem. Okay, so cooling consumes a humongous amount of energy in all assets type. And particularly for this audience over here, you run a lot of factories and they consume a lot of energy for cooling. So the way we want to deliver savings to you is very unique and different from the rest of the world. Typically, when you think about energy efficiency, you think about equipment change. For example, changing of lighting to LED. For example, as a consumer, you will consider changing your refrigerator, your washing machine, or your fridge to a more efficient equipment. I think all these are nice and good, but as a business owner and operator, buying new equipment adds a lot of burden to your balance sheet. So what we are trying to do over here is we ask you to just sit back and focus on what you are good in. Focus on your operation. BBPP will come in and deliver energy savings to you. So we will come and access your facilities. And if we are convinced that we can deliver you savings, we will invest in all the hardware, software, and implementation to deliver you savings. If we deliver $0 savings to you, we don't collect a single cent from you. That is our business model. So there's no financial risk on your part. And additionally, on a year-on-year basis, we will bring in an independent third party, a company like TUV or DMV. They will go to your facilities to do an annual audit and certify that BBP's technology has indeed delivered X amount of savings. Then we take a portion of the actual savings as our service fee. That's our business model. So zero financial risk on your end, and the technology that we are installing does not disrupt your 24/7 operation. So far, we have been very proud to have implemented this technology, which, by the way, is patented in Singapore, in Taiwan, in China, as well in South Korea. We've implemented this across multiple blue chips company. If you look at the semiconductor industry, we have deployed this in 3 of the world's top 10 manufacturers: Micron, Global Foundries, and ST Micro. We've also worked with major players like Luminex, Silterra, and UTech, implemented it on many of their facilities across Asia. And if you look at the industrial segments, data centers or district cooling plants, this has been implemented across many Fortune 500 companies. And on the right-hand side, some of the world's largest commercial real estate companies are also using our technology. So how do we do it? I think that's always the question, right? What is your secret sauce? There's nothing secretive about it, to be very frank. Okay, if you look at the equipment in the orange color bubbles, these are the equipment you will find in your chiller plant room. You will have a couple of chillers, 10, 20 pumps, cooling towers, and your air handling unit. The reason why your chiller plant is consuming a lot of energy is because usually you run it at a fixed set point. And usually the set point is close to maximum for a simple reason. When your load and demand changes, you do not want to fall short of what you are delivering to your shop floor. Yeah, but by doing so, you are wasting a lot of energy. So what we do is we come in and we install 3 things. We install sensors and we install controllers. After that, we put in our patented software. Our sensors, controllers, and software work together such that they will control your equipment in terms of their speed based on actual load and demand, based on actual weather condition. So by doing so dynamically, it allows you to squeeze out energy savings. And we have delivered so far up to 40% energy savings in many 24/7 operation around 9 countries in Asia. Okay, many people ask us, what is so unique about BBP's solution? There's so many energy optimization company out there, right? So this is typically what the other company are trying to do. In your building, your chiller plant is likely connected to your BMS, your building management system. The BMS is essentially a big dashboard that your facility team use. The lightings are connected to it, the fire alarm, the sprinkler, the security system is connected to the BMS. So you know at any moment in time what went wrong in some of your equipment. So most of the energy optimization company out there, what they do is they just build an IoT platform, sensors, and they try to pull data from your BMS, right? And they send it through their software and they optimize and they try to send a set point back to the BMS. All this nice and good on paper, but we know dealing with building management, the BMS seldom gives you accurate enough data to do optimization. That's a fact. And even if they have accurate data, by the time you finish optimizing and send a set point back to the BMS again, the BMS vendor is not going to open up the source code for a third party to write their new set point into it. So many times it results in a lot of frustration, inaccurate data, and the inability to write new instruction set into the BMS. Yep. And this was what BBP was founded 10 years ago when we started. We focused on this and we had a lot of challenges. So subsequently, we pivoted to this model where if we are convinced that we can deliver actual savings to your facilities, we will just come in and install the sensors, the controllers, and the software directly. Interact directly with your equipment and optimize your equipment directly. That's what we do. And through this process, you know, we continue to work with your engineering team to monitor your equipment remotely. As and when your equipment drift, we will inform your facility team to go and fix those maintenance issue or operational issue. So in this sense, we are partnering with your engineering team to constantly upkeep your equipment to make sure that they are running at the optimized level, because our interest is 100% aligned with you, wanting to deliver maximum savings. Okay, so, and by doing so, this is how the remote monitoring looks like. Your facility team will have access, a web-based access to a chiller plant monitoring system. They can look at their individual equipment performance 24/7, anytime, anywhere, on their iPhone or their Android phone. MES is a new regulation that was passed by the National Environment Agency of Singapore back in 2019. It requires majority of the manufacturing facilities in Singapore to meet a minimum energy efficiency standard by 2025. Yep. And McKinsey did this study for BBP with the help of Enterprise Singapore. In fact, Bo was here this morning from McKinsey. He gave a talk. Bo was involved in this project as well. So McKinsey picked the semiconductor sector in Singapore, and they came to a conclusion: to meet MES standard, most of the semiconductor fab will have to spend about 20 over million Sing dollars to change out many of their old chillers. Yep. But they also realized if they partner with BBP using our optimization strategy, they could end up with two scenarios on the left-hand side. Some of them could end up meeting MES standard without paying a single cent of capex because their existing equipment are already good enough. Through optimization, they can already reach MES. Whereas there's another group of customers or industrial players that can reach MES just by paying a fraction of what they were planning to spend. So rather than spending 20 over millions, a $6-7 million capex will bring them to MES together with an optimization solution. And we have been helping facilities in Singapore, semiconductor wafer fabs, meet MES standard since about 7-8 years ago. I'll give you two examples over here that has won us national award at the Energy Efficiency National Award some years ago. The first example is Luminets. This plant is in Yishun. In fact, when they came to us about 8 years ago, they were already having some challenge with a 14-year-old chiller plant. Yeah, we went in, we gave them our zero capex energy optimization solution, and we helped them to deliver about 27% worth of energy savings. And if you look at this number now, in fact, in today's electricity tariff, the amount of saving is worth closer to 900,000 Sing dollars per year. And if you look at the chiller plant efficiency at 0.64, it's already meeting NEA's MES standard, way ahead of the compliance deadline. All done with zero capex by Luminets. And this chiller plant is already almost 22 years old and hasn't gone through major equipment change. Yep. The second and the last example I'll share here is HP at Depot Road. This is also a 24/7 operation, and through an optimization collaboration with us, we also delivered to them MESS standard for their low temperature chiller plant at 0.64. Okay, I've come to my last slide. So all in all, we are now in about 9 countries. I'm very proud of this technology, which is, made in Singapore, and we have brought this to about 9 countries. We have helped blue chips companies save about 26 million Sing dollars in total, and helping them to avoid 100 million kg worth of CO2. I think this matrix will become more and more important in the years to come, especially for many of you in the audience. Yeah, your regulator, your shareholder will consistently demand you to come out with a sustainability roadmap and reduce your carbon footprint in time to come. So we look forward to work together to bring, our business towards better sustainability and net zero. Thanks very much.
Thank you very much, Mr. Ho. Our next speaker is presenting on the topic of rethink water treatment, save energy in manufacturing site cooling. So please join me to welcome Mr. Lim Wei Yang, Director, Destin Plastics Private Limited.
Hi, good afternoon, everyone. I'm Wei Yang from Destin. So we have been working with industry leaders across from commercial, industrial, data centers to change the approach that they have taken to treat their cooling tower water. By doing so, we have helped them to reduce their energy, water, chemicals, and maintenance. A time to rethink water treatment. Work smart, not harder. So today's content, we'll be looking firstly at why are we even looking at cooling? We'll then explore, is there a smarter way of managing water in cooling? We'll then look at 3 case studies. The first, a clean room. Second, a plastic injection motor. And third, a commercial building that is already green mark platinum. So why look at cooling? Cooling is a very significant portion of our energy bill. So according to a study done on a fab in Hsinchu, Taiwan, which is published in 2020, cooling takes up about 27% of our energy bill. Now, out of this 27%, 5 to 10% of your energy is actually wasted if you are using traditional chemical methods to manage your cooling tower water. 5 to 10%. What does this mean in actual numbers? For a typical fab in Singapore, your cooling load ranges between 2,000 to 20,000 refrigeration tons. A 5% reduction, or rather 5% wastage of the energy for cooling translates to a wastage of 5 million kilowatt hours in a year. 5 million kilowatt hours. How much is that? With the rising energy costs in Singapore, this is a very big amount. Now, on top of that, with traditional chemical methods to manage cooling tower water, you are throwing away 5 times more water as compared to new methods. For a 20,000 refrigeration ton fab, you're looking at 78,000 cubic meters of water in a year. These are very, very significant numbers. There is a very big imperative for us to look at how we are managing our cooling tower water and our cooling systems. Now let us change gears. We take a step back and look at general cooling. Right, for all our fabs and facilities in Singapore, big cooling loads, typically we are running what we call water-cooled chilling. Right? Your chillers will be taking the heat load from your process, from your facilities, your clean rooms, for example. All this heat load that is removed from your facilities has to be ejected into the environment. Typically, this is done in 2 methods. You either go with air cool, ejecting it directly into the air, or you go with water cool, which is ejecting it into water and then evaporating the water to take away the heat. Traditionally, we have always used water cool for big cooling loads because that is the most energy effective. However, when we are using water cooled methods, there are 3 main problems that we always have to look at: scaling, corrosion, and biofouling, bacteria. For today, we will be focused on scaling because that is the main problem when it comes to energy efficiency. Now with scaling, the biggest problem is that scaling is actually a very good heat insulator. You imagine a very good heat insulator on your heat exchange surface. Very good heat insulator on a very good on your heat exchange surface. How much more energy do you need to generate the same amount of cooling? Not only that, scaling built up in your piping restricts the water flow. Your pumps have to work harder. So why does scaling happen? Right, with the operation of water-cooled systems, as I mentioned earlier on, the heat has to be ejected into the atmosphere. This is normally done using cooling towers. We evaporate the water to take away the heat. Now the thing is, when we are evaporating water, inside your water you have minerals. You have dissolved minerals. All these minerals, what happens to it when you evaporate water? These minerals get left behind in the remaining amount of water that you have in your system. And over time, this concentration will build up until a point. We call it saturation point. When the water can no longer hold more minerals, and it will then precipitate out as what we call scaling, which causes all the problems that we talked about earlier on. Now, with traditional methods of managing cooling tower water, first step is we delay the saturation. We delay the saturation, we force the water to hold more. But we cannot infinitely delay the saturation. Eventually, your concentration will still hit saturation point. And then what does chemical methods do? We dilute. We throw away water. We throw away the concentrated water and top up with fresh water. Do we see a problem here? We are throwing away water for no other reason except simply for dilution. The second problem, all this water is laced with a lot of chemicals. All the chemicals that we have put in to handle scaling, to handle corrosion, to handle bacteria. All these chemicals are being thrown away together with the water. Is that a problem? Now on top of that, to handle scaling, we are deliberately keeping the water more acidic than it needs to be. To handle scaling, the pH is lower. Now, when you have a lower pH, corrosion of your equipment goes up. So do you want to save energy or do you want to protect your equipment? So all these problems we are facing with traditional chemical methods. And yet, we still suffer from problems of scaling. There is a gradual buildup of scaling when we are using traditional chemical methods. So this leads to a deterioration of our energy efficiency. So is there a better way? Yes, there is. Otherwise, I'll not be here. What if we directly remove the culprit minerals? We directly target the calcium, magnesium, and silica. So using electrolysis method, right, we directly plate the calcium, magnesium, and silica in the water onto electrodes. And then we use a bit of water to flush out the scaling minerals. With traditional methods, the principle of operation, the modus operandi, is to force the water to hold more. Force it to hold more. In contrast, we are directly removing the scaling minerals. In terms of water use, as I mentioned earlier on, traditional chemical methods, you are using water for no other reason except to dilute. Now, the water use is for flushing as a form of carrier to ensure that the system is operating properly, this electrolysis system. In terms of scaling, with traditional chemical methods, we are talking about a tolerated gradual buildup of scaling deposits, a tolerated deterioration of your energy efficiency until your annual shutdown. All that energy is lost until your annual shutdown. With electrolysis method, because we flip the approach around, we are able to prevent scaling. And not only prevent, but we also remove existing scaling in your system, even in the piping. So in the piping in the past, no one can do anything. You change your entire piping, right? That is a big capex. Now I can even remove the scaling in the piping. So with traditional chemical methods, you are forced into two direct trade-offs: water versus energy, and scaling versus corrosion. You want to save more water, you run into scaling problems and energy efficiency issues. You want to save more energy, you have to throw more water. When you're using electrolysis methods, you do not have this trade-off. You can save both energy and water. And because you don't have a scaling issue, I no longer have to keep pH low. I can push the pH higher to maximize both anti-scaling and anti-corrosion. Right, so the first case study is a clean room in SimTech. So this particular clean room is used to house an electron microscope. And over here in this clean room, they are running two water-cooled package units, only 5 years old, only 5 years old. So the difference between a water-cooled package unit and a chiller is that water-cooled package units, you are not able to clean the heat exchange surface. So whatever scaling that is built up in these 5 years remains there. Contrast this to chiller, where you can do an annual shutdown, you can clean your heat exchange surface. So the problem for them, right? Firstly, their energy efficiency was deteriorating over time. And secondly, they were getting very inconsistent clean room temperature. After using an electrolysis approach, we changed the approach, right? Instead of forcing the water to hold more, now I directly remove the scaling minerals using electrolysis. They were able to save 17.5% in energy from their cooling. Temperature deviation from set point temperature went down from 1.5 degrees Celsius to 0.04 degrees Celsius. The key takeaway here is that scaling can quickly deteriorate the performance of your chillers. In 5 years, you can see, in 5 years, their chillers deteriorated 17.5%. And they were having big temperature deviations. So you can see over here in this graph, right? Before implementing the electrolysis approach, their power consumption was very high, it was very erratic. After putting in place such a solution, after 2 months, this energy consumption went down and becomes very stable. This is also reflected in terms of the temperature. Over the graph here, you can see, right, top graph, the blue color data point, blue color line, that is the set point temperature. Red color is actual measured temperature. You can see that before, their deviation from the set point temperature was as big as 1.5 degrees Celsius. After cleaning up, it went down to 0.04. And this also translates to the humidity. The second case study is at Sanwa. It is a plastic injection motor, well-known plastic injection motor in Singapore. So this case study was collected, the data was collected over a period of 7 months. So over here, the processed water is used from the cooling tower into what we call a temperature control unit to heat up the water. And this water is then pumped into the tool in the process. So the supply temperature was set at 110 degrees Celsius, but the process temperature requires 100 degrees Celsius. Well, the problem they had was, again, inconsistent process temperature, wildly changing. So they were running into quality issues. They were running into increased downtime for maintenance. And because of that, this wild fluctuation in temperature, they had to reduce the cycle time. Because by reducing the cycle time, they are able to cater for this wild fluctuation. When they changed the approach, what happened? The temperature control unit's energy usage went down by 25%. The temperature fluctuation, maximum to minimum, went from 13.8 degrees Celsius to 1.9 degrees Celsius. So it's quite consistent from what we see, right, earlier from a clean room temperature deviation. So what we see at their site, right, the temperature control unit was not able to hit 110 degrees Celsius because the scaling had reduced the effectiveness of the heating element. At the tool site, at the process site, they were not able to keep a consistent temperature because firstly, the scaling reduced the flow of the water through the mold. The scaling also reduced the heat exchange in the cooling channels. So this is the actual per minute data that was collected on their process. March, that is the baseline data before any change in the approach. You can see the temperature fluctuation, maximum to minimum, 13.8 degrees Celsius. On top of that, they were doing maintenance every 2 weeks. They had to trigger they have a set point where if the tool process temperature falls below 90 degrees, they will trigger unscheduled maintenance. So you can see in April, suddenly improves because the set point was triggered. So after cleaning, it improved. And then it started deteriorating again. But after putting in this electrolysis approach, what happened was that gradually, right, as it's being cleaned up, this temperature range became gradually smaller. So remember earlier on, right, we mentioned the process temperature was supposed to be 100 degrees Celsius. Now they were hitting 104 degrees Celsius. No change except by changing the approach to managing the water. 104 degrees Celsius. So we told them, look, last time you require 100 degrees. Now you're getting 104. Why don't we reduce by 4 degrees so that you don't need to waste all this energy? So this is what we did. In August, they reduced by 4 degrees Celsius. And they can still hit all their process requirements. Again, this is reflected in terms of the energy savings. Initially, we are looking at 6.2 kilowatt. Right, that went down all the way to 4.02. The third case study is Keppel Bay Tower. This is a 14-month study done in conjunction with BCA. So back in 2018, Green Mark Platinum was the highest level of energy efficiency. BCA wanted to push the boundaries to see how much further can they go. So they had this thing called BCA's Super Low Energy Building Challenge. So we were one of the technologies that was test bedded in Keppel Bay Tower for 14 months. All the data was collected by Johnson Controls, sent to a third-party ESCO, and then all these things, data, reports, went back to BCA's panel of experts where they scrutinized it. This building was already Green Mark Platinum. It has an auto tubing system. It was running chemical treatment. The result, we improved the energy efficiency by an additional 7.1%. Bear in mind, this is already previously a Green Mark Platinum building. We also reduced their blowdown water by 80%. So this is the makeup water report. You can see over here, the cycle of concentration, which is a measure of the water efficiency use, went from 8 to almost 40. Unheard of. You talk to any chemical guys, even with their most advanced technology, they'll be pushing 14. Here we are talking about 40. The makeup water reduced from 7.2 meter cube a day to 1.34. We also looked at the kilowatt versus RT, basically how much energy you need to generate per cooling load. And we did a quadratic regression to analyze, to do an apple-to-apple comparison. So the baseline data, chiller plant, 0.619 kilowatt per RT. After 2 months, we already see an improvement by 5.65% to 0.584. Very good. After 14 months, went down even more, 0.575. 7.1% improvement. Remember this particular banner here? This 20,000 RT, 5% energy savings, 5 million kilowatt hours. Do we still think that 5% is unrealistic? A Green Mark Platinum building achieved 7.1%. This is purely by improving the heat exchange efficiency, not through optimization. Optimization, they have another level. So for Destin, our system is using electrolysis. We call it decay-on or DCI in short. It uses electrolysis to manage the cooling tower water. Now we bring together water and electrochemistry know-how and using that to improve the efficiency of the electrolysis process. On top of that, we tie in our own antibacterial technology. It's a biotechnology that interferes with the bacteria feeding cycle. So this is a supplement to the electrolysis process. When we first launched this product in 2014, we didn't have category. And we ran into bacterial issues because electrolysis alone is not able to handle bacterial issues. Now we tie all these things together with our automated controls, where we automatically adjust to the change in water quality. And we also do automatic self-cleaning and flushing. So this will help with your maintenance people's workload. So this technology, as I mentioned earlier, right, we have deployed it across many industries, right, from the commercial to industrial. So these are just some of the users of our technology. So you can see over here, across from commercial, Keppel, UOB, they're using our system. Industrial side, 3M, Penduit, Linde, Microchip, you might guys are familiar. On the food and beverage side, Hoka, they're using our system. Barry Callebaut, they're using our systems. Even the medical side, in Australia and New Zealand, many of their medical boards are using our system. So with that, I thank you for your time. And if you have any questions, we actually have a booth next door, and feel free to drop by. Thank you so much.
Thank you for your presentation, Wei Yang. And now to talk about the topic of labless vision to build a robust ecosystem, please welcome Dr. Zhang Xi, Deputy General Manager, Wintech Nanotechnology Services Private Limited, up on stage.
Good afternoon. I'm very lucky to be the last speaker. First, thanks SSIA to invite Wintech to give a short speech on this local system, labless vision. We are from Wintech. Okay, Wintech is doing the failure analysis and the material analysis plus reliability works. Most of the semiconductor industry companies are our customers. Although you may not know us, some of them, but your colleagues may be working with us on some of the failure analysis work. Okay, so we are been in Singapore for about 18 years. The company was started in Singapore. And now we expand into China. China have a much bigger footprint, have 3 plants, but Singapore still have 1. Okay, let me go into the details. The Lapless vision actually created by Mr. Li Xiaoming and our president. He get inspiration from the fabless concept. I think one of the reasons for that is because of the emerging semiconductor industry in the emerging market, and also the technology involvement developed so fast, and a lot of new demands now triggering a lot of problems like investment on the analytical equipments and also the talent management. Okay, when he summarizes in one of the articles we publish in our WeChat office account, and it will get a very good response from the industry, especially in China, because in China, semiconductor is boosting and there are really lack of talents. I think this is, everybody is aware. Okay, and with this concept published to the market, and he also get the award for the Fortune Times. This is a Singapore magazines, financial magazines. And we also featured in the SSIA in last year. Okay, this is the details you probably can find on the website. Talking about the fabless concept, Mr. Lee identified some intrinsic challenges to do internal labs, self-built labs. Let's say you are a wafer fab and you are, assembly house or whatever. As long as in the manufacturing or the R&D of the semiconductor industries, you definitely need a lot of so-called analytical services or the analytical works, because you need expert in material science, in the physics, in the electronics, and the tools to analyze your IC chips and your material also have a wide range of equipments, and the equipments are also evolving. So the first things, the challenge we are facing is, first you need to get the equipment. Equipment is normally now with the nanometer level analytical capabilities, that's easily $1 million one, and you may need to get the investment from your CapEx. However, sometimes you're wondering, if I'm doing a development work, I only buy the one machine sitting there, I use it once per week, then would that worth or not? So that's normally the financial justification challenge you are facing. Okay, the second part is the barrier is the talent. The analytical works, the talent may be slightly different from your mainstream product, so-called design or the manufacturing talents. Okay, for example, I'm from originally from manufacturing aspect of the assembly materials. So for me, analytical equipment is very different. I know how TEM works, but you want me to explain to our customer in depth about all different kind of TEM tools, I will find it very challenging. This is a very honest opinion. So, however, those talents in your companies, sometimes they find the glass ceiling because they are supporting roles. They are doing the failure analysis work. What they can do, what they can learn, there's a certain limitations for that unless they move out of the analytical works. So that's the so-called talents barriers we are normally talking about. And maybe their talent are very narrow in a certain, but with a depth in a certain field. Okay. Another area is a technology barriers. For example, the equipments. The equipment technology has also evolved quite significantly. I give you an example. We have two TEM in Singapore. TEM is the transmission electron microscope. This is to see the nano structure of the materials, and you can do the chemistry analysis. And these two machines, one is about 10 years old, another one is about 4 years old. Okay, the 4 years old, of course, is lately we installed. When we installed the second TEM with a new advanced technology, and with even increased the price, and more than 90%, even probably 95% above our customers would rather choose the new machines. So in there, our second machines kind of like in the idle, only a very limited customers are willing to use, because compared to two images, one is much more sharper. You probably choose the sharper one. But imagine you are the one invest on those equipments. After 10 years, the machine, although still working, but is not preferred. So in a sense, the equipment investment and the involvement is also a barrier. And that's why this is normally, you can foresee, easy to understand. That will be the challenge you are facing by you guys. Okay, this is just a simple math. Let's look at the equipment. I do a very, very, very simple math. Let's say you are interested to purchase equipment by $1 million. Okay, $1 million, normally you choose to 5 to 10 years depreciation times. Okay, depends on the company. And the labor source, you need 1 engineer to run the machine. If it's $1 million machines, it's not easy to get a so-called less educated talent to work on. You probably get a bachelor or at least a master to run. So let's say the salary of about 5K to 10K range. And the machine, you also keep it running with all these electronic board, inside the machine, so fully automated. You need to have a service contract as well. Okay, here I put a 10 to 50K service contract, actually easily 50K US dollars per year, even if you don't use the machine as a standby. And consumables, let's say you have iron source, all these things, you probably have, I put a very small amount. So with that, simply calculation, you'll get about about 2 to about $250,000 to about 200K, 300K per machines. Of course, when you're doing IC design or doing even a one process analysis, one equipment, that's not enough. You probably have way more equipment. I would say later on I will show the equipments we have. There are quite a lot of equipments. So by doing this, you can see the cost of running actually is very high. In fact, the most expensive one is the labor resources. As you can see here, we talk about 1 engineer. But if you want to have a technical expert, you probably get another managers to run the lab, all this, the cost will immediately go up, okay? So this is just to give everybody a ballpark, this is, if you look at it, looking for the third-party analytical lab with talents, pools, capable skill set, maybe that's a viable solutions to you. That's where the labless concept was raised. So now we talk about capable alternative third-party labs. Of course, we are referring big companies like WinTech. We also have competitors. However, currently in the Southeast Asia, WinTech probably the largest. I will show you the list of the equipments and our so-called headcounts, resources. So for us, there's a few things we do invest heavily on the capital investment on the equipments. However, in order to make the machine run as efficient as possible, the company was run 24/7. Okay, that will help to reduce the machine cost. Of course, the labor part will go up. Also, we invest heavily. Last few years, we invest heavily on the talents, on the technical talent from the market, and we have a lot of expertise. And probably you'll be surprised. We have more than 10% PhD in the company. Although we are 60 people, we have more than 6, 7 PhDs alone, plus some other masters, all this. So the company really want to put the effort on the talent on that. You probably wonder why the PhDs like to work in WinTech. One of the things, besides, of course, the salary, all these things factors. Another thing is we can get into contact with the whole industry. Because for example, I'm from the assembly material. I'm doing bonding wire, solder material related for my last 20 years. But when I came to WinTech, the first 2 years, I probably experienced more than 200 cases, different customers. So you have all kind of a funny, challenging, or some is easy. All these challenges will give the job satisfaction of those expertise to work in a company like us. Because then they can exercise their knowledge, last weeks, we worked with one of the companies doing assembly. They have a copper migration or diffusion. They are not very sure, and they have been this they have been hunting by this issue for more than 10 years. Actually, it's come from a leaf frame, but they see the failure. They cannot explain very well, and they cannot explain very well. They cannot have the justification to change the bill of material. That's why they have been ding ding dong dong like that for a very long time. So when we take over the case, because leverage our background on the material science, we also provide basically the failure model for them and why, and using also our TEM to justify the models through the evidence. I think with that, they are much more convincing to their management about the bill of material change. Okay, and that's the second part. The last part is we develop unique process, because for failure analysis work is not a chemistry. Normally we think about chemistry analysis. You have a liquid, you pass to the lab do a test, pass the result to you, done. Actually, it doesn't work that way. So a lot of things link to the sample preparations, how to extract the sample. Let's say if you got organic on the piece of material, how to get rid of the background, all these things. Otherwise, you get the mixed signals. It's very hard to explain. So a lot of things to do with the sample preparations. I think that part, we also develop a lot of SOPs to deal with the right kind of, the challenging sample preparation requirement. Okay. Last part is the neutral critical technical analysis service provider. Because as a third party, we are definitely way more neutral. And we look at things, there's no barrier of so-called burden of from which part. For example, assembly part, the die crack come to us, we find out the root cause on the die sawing. Of course, the die sawing guy was not happy, because why you say it's die sawing, and they're arguing with the failure analysis guy, and the assembly guy said, you see now, our third party already proved it's your fault. For us, no matter how angry you are, we are always trying to be neutral and calm. We will explain to you that's the material science. We have no base to go against any of the so-called customers or which departments that you are. So that helped us a lot to help the industry to solve the forever arguable issues we are facing. Okay, and here I show you, this is one of the buildings. We are under construction in Suzhou. That's where we our headquarters. And currently in Suzhou, we have about 300 people there in China. Okay, now to show some of the, because we want to be part of the ecosystem of for Singapore semiconductor industry. So our business are also growing, also come from the investment. As you can see, the revenue, the right line, revenue is going up. The first on the so-called on the left chart, and also below the headcount. The headcount we are trying to maintain around 60 people. I think although it will gradually go up a little bit, but we are still trying to maintain. By doing that, it tells you the company is trying to be more efficient. I think this is a very good chart to show we are getting better, stronger, and of course this will help to expedite your requirement. And also the space, the right-hand chart will show you the space, the red line on the right-hand chart. As you can see, we are keep on growing, because this year we are going to rent another new area, new space in the science park to host more equipment. The reason is that we believe we need to grow and increase our portfolio. With that, we can serve the industry better. Otherwise, we are only think about the cost control, all these things. Imagine when the labor costs go up. Today, the key words is the talent, right? So with the talent, the salary goes up. You are not going to be so-called be robust enough to survive. So that's the reason we are trying very hard on headcount control and efficiency at the same time to grow. Okay, another part come to the service is the speed. Sometimes we call ourselves labs, but honestly speaking, from for manufacturing guys like me, I don't like a lab concept because a lab is like I'm wearing the white suit, I'm not rushing, I'm slowly doing my work. So we also changed that mentalities the last few years. As you can see, our cycle time from 2019 about 3.6 days to about 3 days on average, last year data. So in general, you give us the result. We are within about 2 days. We can give you the result first, then we give you the report. On average, here is the whole year's average of the cycle time. So I think that 3 days, I think, of course, we are targeting for even more. But bear in mind that sometimes we need to do sample preparations, which will take a little bit time. I also need to discuss with customer. And also you can see the green line, the customer accounts, number of customer, we also observe increase, okay. And we continue invest, do the investment on the hardware. This is a few equipments of 4 facilities we increased for the last 12 months. For example, we just installed the CSAM, the latest CSAM, which have a very high resolution. If you need high resolution, here is the good opportunity we can help you. And also we just installed the thermal emissions for the failure analysis on the packaging level. That will be very useful. And we also upgrade our AMI and OBURG. So for this, the PEM for the backside probing for the flip chip device, we can use this. Then lately, we also have a joint work with Emina and Tektronix. We are working on the nano probe to help on the transistor level of failure analysis. So we just installed the machine. We also have a IAE, and we have been continuously invest on the new equipments and the portfolios to help the industry. This is the list of the equipment that, like I say, this is a full process of failure analysis. You get a visual inspection, and IC curve, IB curve measurement. Then you do a fault isolation, sample preparation, physical material analysis. Of course, you can see almost all the equipments will cost you, about $500,000 to a few $1 million, and it's a very so-called capex intensive. However, last 2 years, the equipments we already highlighted in the orange box. As you can see, the company has been continuous invest. Okay. Headcount, the talent is one of the things that today has been discussed quite. Here I'm okay to show to everybody. This is also the headcount in and out we are facing. In general, we are facing about 20% turnover. As I look at it, there's nothing to complain. When you have a high turnover, maybe the way you train your staff are not, if your staff leave a black hole, that's the management issues you have to face. And we are trying to improve and also trying to help to train the new companies, new employees. And recently, I think it's getting better, around about in and out about 20% range. I think this is probably the industry norm. And one thing I want to highlight is that just like the talents we are having with us actually help the industry. Okay, so honestly speaking, we have many so-called colleagues, ex-colleagues from WinTech, left WinTech to go outside for working for another 10 years, 10 years plus, and even return back. When they return back to WinTech, they find actually the skill set is a little bit not able to catch up with the latest technology. Because you know why? Because we are dealing with various kind of customer requests, and also the culture, the speed is also different. So what I'm trying to say is that in general, we are like we are a hospital for the community. So, and this is the role we can help more customers, help the local industries, and and WinTech, definitely I want to make a statement. We are not trying to target any of our customers to of course, through our last 18 years, we also have a good reputation that will say that will help us to grow. Okay. The last one is from the business model side. In order to equip the labless, let's say we are encouraging you to go for labless concept. There's a few ways we can help you. One of the ways, the traditional way is we are helping to do the failure analysis work. That's the fundamental basic. Of course, for the small companies, startup companies, or you have a very small amount of business, one of the things we can work with you on the service contract. Okay? Because if you are a startup company or you have less so-called failure analysis work, we can give you a service contract. You have a fixed cost running. So, of course, there's a certain threshold, so you get a discount. Then you get, the same fixed price for the every month. And we will help you. You will help us as well. So this is one of the business model we start to work on some of customer. But if your business is go up and down too much, your internal justification is challenged. We understand that. We are okay with that. And we also trying to encourage some other new models, let's say joint line management or even the joint purchase. Okay, because if you don't want to have a so-called management, you are willing to purchase the equipment, but you don't want to have a management of the equipment. There's a talent part. We also can work with you on the so-called tailor plan, how to manage on that. In general, we are a small company. 60 plus people in Singapore is a very small company, I would say, compared to you guys. So, but we are very flexible, and we really want to be the local ecosystem, the contributors to help the industry. Okay. So I think our aim is to be part of an ecosystem. Of course, if I miss out any of your segment, I'm sorry for that. And at the same time, our focus is we want to be fast, because I believe speed are really, really important in the current business world. Of course, best on the quality side, because the resolution, the workmanship, less errors. The last one is the most value add, because I believe if you just treat looking for outsourced service, doing a test, you're going to interpret the result, the value is very limited. If we can help you with our industrial background and help you to decode your failure, and that will be much more value add to you. I think that's our visions. Thanks everyone. Thank you very much.
Thank you so much, Dr. Zhang. And with that, we've come to the end of the Semiconductor Business Connect 2022. Thank you everyone for taking the time to attend this event, and we hope that it has been insightful for all of you. And we hope to catch all of you in person at our next event. I wish all of you a great week ahead. Take care and goodbye.